In the last few decades, the power of telescopes has advanced almost exponentially. We went from being able to see some stars in some frequencies to now pretty much seeing the entire universe in pretty much all frequencies. But more importantly, automation and artificial intelligence now allows astronomers to scan huge parts of the night sky and discover any changes or discover any anomalies pretty much right away. And one of the more intriguing projects that we've discussed previously, that's mostly focused on the Milky Way's bulge and basically our own galaxy, is known as VVV, Vista Variables in the Via Lactea. It's been going on for almost 14 years now, and it's mostly focused on changes in star brightness or something else changing in a star, in order to then help us understand something we've never known about before or potentially discover some hidden mysteries. And intriguingly, we've discussed this particular survey before because in the last few years, it did actually discover a lot of missing stars. There's actually over 1,000 now, but basically these were stars that were visible back in the 50s, in the 60s, and are not visible today. Now you can learn more about this in one of the previous videos in the description, but in a nutshell, it's unclear exactly what happened to those stars and if we've just discovered some kind of a new unusual phenomenon. But discovering a new phenomenon should not really come as a surprise, because these new telescopes have been doing just that for the past few decades. New unusual phenomena, new unusual discoveries, and new unusual stars. And now the scientists have discovered another unusual star we've never known about until now. It does not have a really cool name yet, but their nickname for now is Old Smokers. Ancient stars that turn out to be very unusual compared to anything else. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries from the V survey, find out exactly what these stars probably are, and also discuss some of the other mysteries discovered in these studies. And mostly because a lot of these discoveries can potentially finally explain why some stars seem to have vanished, as you can see from this image, and as you can learn more about in one of the videos in the description. Because the phenomena discovered in this particular study could maybe explain some things. And so here's what we know so far. When it comes to this survey, it's mostly focused on this part. And it essentially tries to focus on specific areas in order to identify long-time changes. And though the main goal for the survey itself is just to find different types of variable stars, mostly because quite a lot of them are usually used in, for example, distance measurements, in this case, these particular studies only wanted to focus on young stars. And here we're talking about really young stars. Stars that are not even stars yet. Basically, stellar precursors, or sometimes known as YSO, Young Stellar Object. The central objects that will become stars, but are still growing quite dramatically, and usually changing luminosity by huge margins. For example, here is a snapshot of a light curve for a very famous such star known as Fu Orionis. You can learn more about this star in one of the videos in the description, but as you can see here, even in a single year it changes quite dramatically, and it's actually difficult to predict how exactly it's going to change or by how much. As a matter of fact, if you look closely, you'll notice that around 1935, it suddenly started to dramatically increase in brightness, but in the last few decades, slowly dropped in brightness, and is continuing to do so right now as well. Now, because in this case the scientists are basically trying to study these young stars and are trying to understand them a little bit more, discovering even more of these objects out there is of course the main way we can do this. And it's surveys like this that easily allow the scientists to discover them. Here's actually another interesting image of similar objects, in this case taken by the James Webb, and this is in the Orion Nebula. Because Orion Nebula is basically a molecular cloud where a lot of baby stars are forming right now, quite a lot have been discovered by looking at various frequencies of light. But because they don't produce a lot of optical light and a lot of infrared light, usually infrared telescopes are the best to try to find them. But one of the studies here was basically trying to find how these young stars transform into actual stars when basically the fusion starts and the hydrogen starts burning. And here they did actually discover at least 32 such stars. This is just a new discovery, so we don't actually have any details yet, but one of the studies in the description discusses this in a lot more detail. But all in all, approximately 200 different variable stars were discovered by the researchers using this new data. And essentially here we had 200 objects that at some point changed their brightness. Some by just a little bit, some by as much as 300 times. with many of them changing the brightness for just a few months, many of them for a few years. And so most of these were very likely these newborn stars that the researchers nicknamed squalling newborns, or basically newborn stars that had a lot of different emissions and would have a lot of outbursts pretty much every year. But there was some really intriguing additional discoveries that nobody expected. But first, what was expected? Well, apart from these newborn stars, the researchers were also expecting to find typical variable stars, like the one right here, that will usually produce periodic changes in brightness. Naturally, quite a few were found as well. Apart from that, typical variables also include things like nova, very powerful explosions around a white dwarf binary, where the white dwarf basically steals a lot of matter from its partner, with that matter exploding on the surface in the process. And the other interesting phenomenon scientists are interested in is what's known as microlensing, essentially a passage of some kind of a massive object in front of a star that does increase the brightness for some time, but very often only once. So this is not something that's going to repeat again, but something that allows us to study these objects and even determine their mass and their size extremely precisely. But of all of these variable discoveries, 21 did not fit into any of these categories. They were somewhat unusual, yet seemed to be pretty much everywhere. These were very large red giant stars that would dramatically change their brightness for different periods of time. Even more dramatic than Betelgeuse and a lot of other red giants we've discussed recently in one of the videos in the description. And all of them seem to be very old giant stars. Basically stars that are either going to go supernova or potentially transform into something else, such as a planetary nebula, in the future. But surprisingly, most of them seem to be in the same region of the nuclear disk, or basically very close to the central bulge of the galaxy that does contain slightly different molecular composition. And further analysis established that these dips are not because of some kind of a planetary disk or because of some kind of a planet around them. They all seem to last for at least a year, often longer, and because of the way the stars dimmed, it was all very likely due to some kind of a small dust. In other words, just like with Betelgeuse, they seem to have this huge dust cloud that seemed to block the light from our perspective right here on planet Earth. But unlike Betelgeuse, there was no pre-existing large mass of dust, suggesting that this dust was actually being created by the stars through some kind of a process, which is why they were kind of nicknamed old smokers. Old stars producing a lot of smoke. And though at first it was not clear what's happening here, further investigations established that all of these stars were extremely high in metallicity, or basically they contain a lot of non-hydrogen and non-helium elements, even higher than our Sun. And this resulted in a higher production of dust, literally making these stars something we've never seen before. Humongous red stars that basically have smoke coming out of every direction. And that smoke changes their brightness by quite a lot. And so because the center of the Milky Way is quite enriched in a lot of heavy elements, this is probably why these types of stars seem to only exist here. But only 21 so far have been discovered, so we don't really know if this is a common phenomenon. Nevertheless, this presents us with a completely new way. A lot of elements, especially heavy elements, seem to be released into the Milky Way by the stars themselves. Not through supernova or through some kind of a major explosion, just through this unusual smoking process. And that of course means that regions of the galaxy with even more metallicity, or possibly other galaxies that are even richer in metallicity compared to the Milky Way, may have a lot more of these stars, and thus have very different elemental composition, or different types of star evolution compared to what we have here. And so definitely quite an intriguing discovery of a star, or a type of a star, we've never seen before, or never knew existed until now. And I guess even more interestingly, even though the study mostly focused on these young stars, in terms of pure numbers, it actually did find more nova than anything else, and at the same time discovered these unusual old smokers. But because the survey is still going on and there's going to be even more data later on, chances are even more mysteries will be uncovered in the next few years. Okay, looks like we have a new record. The researchers, whose paper you can find in the description, have just confirmed the smallest star ever discovered. Smallest in terms of volume or size, not mass. Although in this case, it's important to define what we mean by star. This is still a main sequence star, meaning that it still has fusion. Different from an object like a neutron star that's even smaller in size, or a white dwarf that's smaller as well. But none of those are technically stars. The more accurate term is degenerate star, a star containing degenerate matter, but no more fusion and no more nuclear reactions. In this case though, we actually have what's known as a hot subdwarf, which basically didn't just break a record, but also just sort of rewrote some of the theories behind star sizes in general. Because for a very long time, we always thought that the smallest types of stars are always going to be red dwarfs. So, you know, stars like Proxima Centauri, TRAPPIST-1, and so on, the most common type in the galaxy. Stars that are pretty much everywhere. And stars that were always thought to be the smallest by size. And obviously stars that are the focus of many different studies, mostly because pretty much all of them seem to contain terrestrial planets in their orbit, and quite a few of them contain planets in habitable zones. But that's beside the point. The point is that they don't seem to be the record holders. They don't seem to be the smallest. And so, hello wonderful person, this is Anton. Let's discuss this relatively recent discovery, talk about what this means for astronomy, and obviously talk about the star and how it most likely formed. Because it was unlikely to have formed so small. It was probably much bigger. But it is really small now. And let's maybe start with a comparison first. For this I had to bring out my old friend Universe Sandbox. So here's the Sun, here's Jupiter, and here is Earth. As you can see, the size difference here is pretty dramatic. But it's these two last objects that we're kind of concerned with. So here's roughly what all of this would look like side by side. This right here is TRAPPIST-1, one of the smallest red dwarfs known to us. As you can see, it's just a little bit larger than Jupiter in terms of size, but obviously much more massive. It's about 93 masses of Jupiter. But then this newly discovered star, TMTS J0526, seems to be smaller than Jupiter. It's approximately 7 times as big as planet Earth, which is right here, and thus definitely beats all records, but also beats our previous assumptions about how small stars can get. Here, this object that's approximately 2700 light years away from us seems to contain about 1/3 of our Sun in mass, so actually much more massive than TRAPPIST-1, but is only 63% the size of Jupiter. And it's not even that hot. It's about 2200 degrees Celsius. Technically even cooler than a typical red dwarf. And though if we found this object by itself somewhere out there, it would be one of the biggest mysteries in astronomy, one of the main reasons this object was discovered was because it's in a binary. But a very unusual binary. A binary that has an orbit of just 20 minutes. Actually 20 and a half. So basically every single hour these objects go around each other 3 times. And that's technically unheard of. Okay, it's not unheard of for degenerate stars, so white dwarfs, neutron stars and so on. There are actually white dwarfs out there with even shorter orbits. But in this case, this binary contains that star and, okay, yeah, it's a white dwarf. But that's really important because it actually explains to us how this very likely formed. And so the only reason these two objects exist, have such a short orbit, and one of them is so ridiculously small, is because this used to be a binary system with 2 Sun-like stars. But in this case, a very special binary with 2 stars basically touching. Now, sometimes when these stars just touch and orbit each other this way, we call this a contact binary. But this can be at different levels, farther away or much closer. And sometimes it can actually be so close that they basically start to resemble a single object. This can be referred to as an over-contact binary, or in more extreme examples, a common envelope binary. It basically resembles, I guess, a number 8, or I guess some kind of a spinning snowman. But because these are sun-like objects, with time, as they get older and older, one of them will eventually start to expand. So in essence, kind of like our Sun, becoming larger and larger in a process, eventually losing its envelope, and then, at some point, becoming a white dwarf and creating what's known as a planetary nebula. And so because one of the stars here is a white dwarf, we know that this is exactly what happened to that star. So what happened to the other? Well, here this idea has a name. Binary population synthesis. This other study from 2020 talks a little bit more about this, but in essence, there is a stage in the aging star known as a helium flash. It basically happens when the star starts to burn helium. And during this time, there's actually a relatively large explosion, which, if it happens inside a common envelope, will cause this envelope to escape and to affect both stars. And that can physically turn any sun-like star, or in a binary case, a smaller partner, into a sub-dwarf star that's going to have a total mass of about 45% of the Sun, which is actually something we've seen quite a lot around the galaxy, with a lot of these very similar stars explained in a similar way. But in this case, or in this binary system, this common envelope and this explosion based on the helium flash very likely happened not once, but twice. Specifically because of the second star that now reached its stage. And so because of this, the common envelope decreased in size even more, thus creating an object that's even smaller, a third of the Sun, which is precisely what we see in this particular binary. And so in this case, the theory and the predictions from 2020 explain this really well. And so we can actually only find these really small stars if they have some kind of a white dwarf partner in a very close orbit. And here this is actually, I guess, also a record. It's technically the star with the shortest binary orbit, mostly because all of the other previous record holders were always white dwarfs. And as I mentioned before, they're not really stars. They're degenerate stars, or in some sense, they're basically stellar remnants. But here we do have an actual star in an orbit of just 20 minutes. The star is still conducting fusion and is still in its main sequence stage, something you can read more about in one of the studies in the description. And intriguingly, the researchers here also suggest that this is possibly an absolute orbital minimum. Basically, this is as low as it gets. They don't actually think it might get any lower, because at that point either the star will change as well, becoming a white dwarf, or the white dwarf might start completely destroying the star because of its much higher density and the tidal effects, thus eventually causing nova and turning the star into something else, maybe even a planet. Now, as a matter of fact, at the moment it's not entirely clear what the future of the system is yet and what exactly this will become. But by being such an exciting discovery and such an exciting star, I'm sure we'll have some explanations really soon. Either way though, a really exciting discovery and obviously a multiple record holder and, officially, the smallest star in the galaxy, at least as of 2024. Our galaxy is filled with a lot of really bizarre stars. Stars that are somewhat difficult to explain, or stars that take months and even years to explain. And though quite a lot of these stars end up being unusual phenomena that scientists eventually find a way to explain, there's actually one star out there that even today is a little bit mysterious. And here, I guess let's start with a bit of a history, just so you can understand how unusual this object is. And here the story starts in 1937. Up until this point, nobody even knew this object existed. But then, extremely suddenly, the star magnified its brightness by a ridiculous amount. It went from being only visible with powerful telescopes to suddenly having a magnitude of 9, a magnitude requiring binoculars to be seen, basically increasing in brightness by over 600 times. And though obviously sudden changes in brightness are not unusual, especially if a star goes nova or maybe even supernova, it did become unusual for one reason. It maintained that brightness for practically 90 years, decreasing just a little bit in the last few decades, but overall staying somewhat stable. And so for many decades, nobody knew exactly what's happening with the star, now referred to as Fu Orionis, a star located in the constellation of Orion. And even though at first it was actually believed to be the only such star in the entire galaxy, over time, starting in the 1970s, astronomers discovered more and more such objects, which are now basically just referred to as Fu Orionis stars. Stars that for some reason become extremely bright, practically overnight, and maintain this brightness for a very long time. But we know that such events seem to be temporary because another similar star, V1057 Cygni, also did something similar, but this emission lasted for just a few years. As a matter of fact, it might have done it twice. Here is the most recent such event that happened just a decade ago. And so, hello info person, this is Anton, and today we're going to discuss the mystery of these Fu Orionis stars, focusing on some of the new studies and potential new explanations that essentially try to explain this 100-year-old mystery. What exactly are these unusual emissions, and why do they only seem to affect certain stars? With some of these events potentially being billions and even trillions of times more powerful than a typical emissions from a star such as a solar flare. But in this case, emissions or flares lasting for years and even decades. And while in the last few years, there have been some major advances and additional discoveries that kind of helped us understand what's most likely happening here. although a lot of the stuff was already known decades ago. But here we have some new observations based on data from recent surveys that basically help us see these stars in a slightly different way. And so here's actually roughly where this particular star is located. And interestingly, as you can see, it seems to have its own nebula around it, which is already a telltale sign. A sign that this star is extremely powerful and is also emitting a lot of gas from itself, which when illuminated by powerful photons such as X-rays, essentially forms these beautiful formations. And so in essence, today we believe this is a baby star. Or to be more exact, it's a pre-main sequence star that's not actually ready to be a star yet and is still actively developing. And because it's still developing, it tends to change its own luminosity and even changes its own spectral type. For example, this is actually what happened to that star that increased in brightness in 1969, changing its spectral type from K-type to F-type, which basically meant it dramatically increased in luminosity and also increased in overall temperature. But it's quite likely that all of this is really the result of this, an extremely large dust disk that's accreting matter around the star that occasionally interacts with the star, maybe feeding it, and maybe causing it to increase brightness dramatically. At least that's what was believed previously, based on observations by various telescopes. But here are some of the most recent observations using ALMA, a very powerful telescope in Atacama Desert, was able to reveal a thin gas stream falling into the star by focusing on direct observations of carbon monoxide. Except that in this case, by calculating the mass, the researchers realized that this is definitely not enough to produce these powerful outbursts. So this leftover was actually from probably something entirely different. And more importantly, it didn't really look like the accretion disk here was actively feeding the star as predicted by other models. And so maybe something else entirely was happening in this case. Although here, an older study made a slightly different proposition. The proposition based on this being a binary. And this is of course something we've known for a long time. And more importantly, both of these stars contain their own disks, which means that maybe occasionally these disks interact. And so this disk interaction could maybe occasionally cause one of the stars to suddenly have a much higher accretion rate, which basically forces the star to become really bright for a pretty long time, as more and more gas disturbed by the other star starts to fall onto its surface. And so here, by using computer simulations and focusing on what happens after roughly around 300 years, the scientists were able to recreate a somewhat similar emission when two stars with relatively large disks basically start to interact with one another. And intriguingly, one of the main discoveries out of the study was not the fact that they provided one potential explanation for these stars, it's actually the effects from these unusual emissions on the rest of the star system. Mostly because we know that these unusual outbursts are extremely important in helping various star systems develop chemically, and much more importantly, develop chondrules, unusual round grains found inside various meteorites that basically represent molten or partially molten material that's also chemically modified and results in the production of different very important minerals. And quite a lot of meteorites out there in the solar system seem to possess them, essentially suggesting that something extremely similar very likely happened in the early solar system for reasons that we still don't understand. Or in essence suggesting that very similar outbursts were probably part of the early sun as well. And this by itself chemically changed quite a lot of materials that later formed planets and of course resulted in various meteorites delivering all of this stuff to the surface of the planet. And though it might have been actually caused by some kind of a star system near us, as suggested by these simulations from this particular study, the researchers from the recent study proposed a slightly different mechanism. A mechanism that potentially exists around a lot of stars out there, explaining why we've discovered so many of these FU Ori stars already. And specifically, it's something that relates to the formation of planets. And so this new study focuses on trying to figure out what happens in these baby star systems when really massive planets come just a little bit close to the star. And so here, by focusing on magnetic forces mixed with the drag produced by the accretion disk, the researchers realized that as the planet grows bigger and bigger, in some cases it's also going to drift closer to the star. And planets of certain masses and certain sizes at some point might actually kind of ignite because of tremendous amount of energy coming from the star. Ignite in a sense that they basically start to emit a lot of superheated gas from their own surface, which then starts to accumulate as a kind of a dust ring around the star, rapidly falling onto the star's surface. and so the superheated atmosphere of the planet orbiting the star really close dramatically increases the amount of material falling onto the star, resulting in sudden brightening that can last for a very long time, for as long as the planet is being evaporated and for as long as there is mass to escape. With all of this basically being caused by extreme evaporation of a young gas giant when the temperatures go as high as 30,000 Kelvin. This would be really close to the star, possibly about 4 times closer than Mercury is from the Sun, so approximately 0.1 AU. But the planet also has to be relatively massive, at least 6 masses of Jupiter, evaporating a relatively large amount from the surface every year. Which kind of shows us that planets around young stars can actually not be just created, but can also be destroyed in an extremely dramatic way. And based on observations from other FU Ori stars, if this is correct, it also means that all of this happens super quickly. Moreover, because a lot of stars seem to experience anywhere from 10 to 20 such events in their lifetime, at least based on modern calculations, it also means that this is something that happens many times, with a variety of different planets basically destroyed over time in the first million years of the star's existence. And the main implication here is that the majority of planets that form around young stars are potentially destroyed in this way. As a matter of fact, it implies that most planets, especially large planets, very likely meet similar fate. Which could maybe explain why we actually don't find that many planets around other stars compared to what's, I guess, expected. But naturally, this is once again just another explanation and another hypothesis, and so even now, after basically 90 years, FU Ori stars are still a little bit mysterious. But since only approximately 10 such stars are known to us right now, this mystery is very likely going to remain unexplained for at least some time. More such stars need to be discovered and more observations need to be done before we can have a definitive answer on what exactly is happening here after all. Importantly though, it looks like something very similar potentially happened in the solar system as well, and so this could be important in helping us explain the origins of life and in why the solar system is just so different from everything else. Today we're going to discuss a somewhat unusual object discovered not so long ago, and an object with a somewhat unusual name. This here is currently referred to as Dracula's Chivito. A kind of a funny name, mostly because the founder grew up in a region extremely close to Transylvania, and Chivito is a type of a sandwich from the co-author's home country of Uruguay. But despite a somewhat unusual name, this object is actually super exciting, and as you can see from these images, kind of unusual. But if you watch like every single video on this channel, you probably already know what this is, and you probably are familiar with the second such object, the original one that you see right here, referred to as Gomez's hamburger. In this case, called a hamburger because of its unusual shape, and Gomez was the name of a staff technician who accidentally discovered this back in 1985 in the country of Chile. And so because of the unusual name of this particular object, the second object was also named after some kind of a sandwich. And so, hello wonderful person, this is Anton. Today we're going to discuss these unusual objects once again, but really focus on this, because the recent study just confirmed that this is something not a lot of scientists expected, and it's basically a new record holder. And so let's discuss this in a little bit more detail, but first a really important side note. A lot of these objects were actually discovered relatively long time ago. For example, the picture of this initially appeared back in 2016. And this was initially seen by the US Naval Observatory, but because nobody knew exactly what this was, it essentially remained as a kind of a side note and described as a nebula. But nebula without any specific characterization. It basically just had the name, IRS 23077 plus 6707. And so it basically took approximately 8 years for someone to rediscover this and to then figure out what exactly we're looking at. Or I guess more importantly, link it to this. And we kind of already knew what this was. Gomez's hamburger is basically a young star. It's a protoplanetary disk seen from sideways, roughly around 6500 light years away. And though initially it was actually believed to be some kind of a nebula, specifically a planetary nebula or a result of a sun-like star turning into a white dwarf, additional observations revealed that this was not the case. It was revealed to be a protoplanetary disk approximately 900 light years away from us, with this unusual dark band basically being the disk itself, with the star in the middle also being relatively hot, roughly around 10,000 Kelvin. And these unusual white bands, that's basically light reflected from all of the gas around the disk produced by the super hot star. And all of this became quite apparent once the researchers analyzed the chemical composition. Here they basically saw a lot of different gas, including carbon monoxide, which very often correlates with forming planets. And actually carbon monoxide moving in two different directions, which basically corresponds to a disk and to newly forming planets, with one of the planets potentially even being Jupiter-like, because there seems to be some kind of a clump of carbon monoxide gas. And so when the researchers saw this, here it was very easy to make the connection. Once again, two bonds, an unusual dark band in the middle. So extremely likely something very similar, or basically a disk almost side-on. Here the distance was very similar, approximately 1000 light-years, and the star was also very hot, possibly 8000 Kelvin. We usually refer to these as A-type stars. But it's a lot of additional observations that basically made everyone go, okay, that is kind of cool. Turns out that there is a lot of stuff here. As a matter of fact, it turns out that this is very likely the largest protoplanetary disk we have ever seen anywhere. Because the size here was estimated to be approximately 1650 astronomical units. That's up to 100 times bigger than anything we've seen before in a lot of other star systems, with the total mass of the disk being approximately 0.2 solar masses. And so these two recent papers that you can find in the description essentially go through the initial analysis and then through additional confirmations using different types of telescopes and different types of light. And specifically, because this is a dust disk, the dust hides a lot of stuff, and so by using microwave telescopes, such as the sub-millimeter array located in Hawaii, scientists behind this recent study were able to see through this in order to identify specific features. And so using millimeter wavelengths, they definitely confirmed that this is a spinning object resembling a disk sideways, with different types of gases seen moving at different velocities, and basically in a disk-like fashion, one side moving away from us, one side moving toward us. And it was also seen to be extremely rich in dust and various types of gas, with all of this gas being visible as very bright patches in millimeter wavelengths visible with radio telescopes, with the star itself being possibly 2 to 4 solar masses, but basically entirely hidden by all of this dust. We can actually barely even see it, only visible as these reflection bands formed by the dust around the disk. But it's really the amount of gas here that's really shocking. It seems to have enough material to form many different gas giants similar to Jupiter, but also at distances up to 300 times as far as Jupiter, basically up to 1600 astronomical units. So in a nutshell, at least in theory, if these planets form, this particular star system could be extremely overpopulated with a lot of different planets. Something that we've actually never seen before, and something that would be very surprising. As of today, astronomers have never found any star systems with more than a handful of Jupiter-like planets. And so the evolution of the system is currently super intriguing. Nobody actually knows what this is going to become in the foreseeable future, or I guess in the next few millions of years, but if it becomes a star system with multiple gas giants, that would be super surprising. For I guess at least one possible reason. These types of systems would not be very stable, with a lot of these gas giants very likely kicking each other out or possibly combining. And so maybe one potential resolution here is that this is how rogue planets form, and this is why we actually find so many different rogue planets across the entire galaxy. One of the most recent discoveries from the Euclid telescope was a surprising discovery of thousands of rogue planets in just a tiny patch of the night skies. But maybe on the other hand, this is also how brown dwarfs form as well. Maybe all of this dust eventually combines through various collisions, forming larger and larger objects, such as mysterious brown dwarfs. Or basically objects that are just a fraction of a star's mass, or are almost star-like, but don't actually get enough mass to become stars. Either way though, at the moment this is definitely the largest such object we've ever seen, more than 10 times bigger than any other candidate, and possibly up to 100 times bigger than what the solar system was back in the days, 4.5 billion years ago. And so by itself this evidence is kind of shocking, but also super exciting. Mostly because now the scientists believe that it's quite likely that a lot of these objects have actually been discovered by previous surveys, but possibly missed completely just because nobody actually thought what we're looking at, and some scientists made an assumption that this was just some kind of a nebula, such as a planetary nebula, formed by various ancient stars. But in reality, these seem to be extremely young stars about to form their own star systems. And though right now we've only discovered 2, it's quite likely many of these were missed by various surveys in the past. And it's quite likely we're going to be discovering more in the next few years. Mostly because now the scientists know what to look for, and they can probably use a machine learning algorithm to automatically identify all of these objects in a lot of older data. Approximately 3 decades ago, researchers studying planet Earth, and specifically various micrometeorites arriving to planet Earth from various locations, discovered that for some reason, quite a lot of them were coming from a certain location in the night skies. A variety of micrometeorites appeared to be coming from some kind of a dominant source somewhere out there. And a few studies, some of which you can find in the description below, basically discovered that it seems to be coming from a direction of a star system in the constellation of Pictor. And there is really only one star that's just really bright here, Beta Pictoris. And after years and years of studies, researchers realized that this appears to be the main source for quite a lot of micrometeorites on our planet. Here we're talking about tiny particles, over 20 micrometers in size, arriving to Earth with very high velocities, because they left the star system at 25 km per second. Although exactly what ejected them is still not clear. And so, hello wonderful person, this is Anton, and today we're going to discuss Beta Pictoris once again, because of additional discoveries that were recently made using James Webb Space Telescope, but also because, as you just discovered, this is not just some star out there, this star physically affects planet Earth at all times. And so trying to understand exactly what's happening here, or what's happening around the star, can obviously help us understand how this may affect planet Earth as well. But first here, I actually wanted to start with this beautiful animation. I've showed this to you previously in one of the videos in the description, but this essentially shows us a beautiful time-lapse of one of the planets of Beta Pictoris orbiting the star. This is actually one of the few planets that has been directly observed around any star system, and because this planet has been studied for almost 20 years, it allowed researchers to create this beautiful time-lapse. And so first, what exactly is this star, and what exactly is happening here? Well, it's a young star system, possibly about 20 to maybe 25 million years old, and a star system that's still forming a lot of planets, and has a lot of activity around its protoplanetary disk. And though 2 planets have already been confirmed here, it's expected that a lot more are still forming. The 2 confirmed planets are both gas giants, and this is actually how we believe planets must have formed in the solar system as well. Gas giants first, ice giants later, terrestrial planets at the end. But we've also been able to observe the disk directly, in the process discovering that it seems to have at least 2 parts, with the second one potentially produced by a planet orbiting in a slightly different inclination, producing a misshaped disk. And actually some of the most recent observations by the James Webb didn't just confirm this disk, they also discovered additional shapes, including the one you see right here, scientists now refer to as the cat's tail. Moreover, the researchers also discovered that these 2 disks are different in temperatures, suggesting that they have different materials. With all of this also suggesting an enormous amount of interaction, which potentially leads to a lot of collisions, and most importantly, a lot of the stuff gets ejected. And it's the ejection of the material that's most likely causing some of it to eventually arrive to planet Earth, bombarding our atmosphere and delivering a lot of new materials. Although intriguingly, this is not the only such star around us, because back in 1983, researchers actually found several stars emitting extra infrared light that we now refer to as Vega-like, with the 3 other stars being Epsilon Eridani, Fomalhaut, and Vega itself. And so all 4 stars potentially have something similar going on. But in case of this particular star system, it's actually the disk's orientation. It's basically facing us sideways, and so a lot of dust is orbiting in such a way that if it does get ejected from this disk, it's kind of headed into one of the directions along this disk. And it just so happens that planet Earth is in the way. Although this disk might be a little bit different. It seems to be abundant in carbon as opposed to oxygen, which scientists have suggested might produce carbon planets as opposed to planets like Earth, which are enriched in oxygen. And so studying this disk can actually help us understand how various terrestrial planets form and why the composition of certain terrestrial planets is so different. I mean, one of the main reasons planet Earth is so unique and is even able to maintain liquid oceans on the surface is actually because of the composition of its minerals. The right combination of carbon, oxygen, silicates, and a lot of other stuff forms a lot of important minerals able to create necessary conditions for life. But carbon planets might be something different, and oceans might not be possible here, which is why studying such systems can help us understand what's going on out there. And so when it comes to planetary formation, this is basically a go-to star that will hopefully help us understand everything. Especially because in the last few decades, there's been a lot of signs of different types of interactions, including detections of comets, and possibly even evaporating comets, that have been reported by scientists in 2019. But now we have an intriguing new discovery that was actually just made by comparing some of the older pictures with some of the images from the James Webb. And here it's once again something detected inside the disk, and something that does confirm active planetary formation. And here the researchers focused on the changes in energy. In this case, all of this energy is actually emitted by various dust grains. And so back in 2005, the observations from the Spitzer Space Telescope, the predecessor telescope prior to the James Webb, revealed unusually high energy in two different wavelengths, implying heat emitted by various crystalline silicates, and specifically various minerals that we usually expect around young stars. Yet when observed by James Webb extremely recently, nothing was visible anymore. And this was not some kind of a mistake in the data. These emissions were there 20 years ago, and they were not there now. And so when the researchers collected data with the Spitzer telescope initially, they actually assumed that this was some kind of a natural result between asteroids continuously colliding and grinding materials, potentially producing elevated emissions in certain frequencies, or something that was basically replenishing materials of certain size. Yet the observations from the James Webb imply something else. This was probably a one-off event, and specifically some kind of a cataclysmic collision that essentially happened 20 years ago, with the collision pulverizing the bodies, producing an enormous amount of dust, but after 20 years, essentially dissipating. And because the dust in this case was clearly not replaced, right now this is the best such explanation. And based on the amount of material detected emitted by these collisions, it actually implies a collision between two relatively massive objects. Not planetary objects, but definitely some kind of planetesimals, possibly similar in mass to Ceres, equivalent in size and mass to typical dwarf planets. And because this event produced so much dust, and also because this probably happens quite a lot here, this potentially answers the question of why planet Earth receives so much dust from this location, while also showing us what most likely happened in the early solar system as well. And so the observations from the star system doesn't just teach us about how the solar system evolved and how planets like planet Earth formed as well, it also shows us something much more important. An important source of space dust that's coming to our planet every single second in huge amounts. And though naturally we still have no idea how this influences planet Earth, it's really studies of star systems like this one that can help us understand this a little bit more. And so yeah, this is not one of those studies that's purely astronomical in nature. This is actually something that's definitely affecting our planet, but in ways we still don't understand. Which is actually why we'll come back and talk more about Beta Pictoris in some of the future videos as well. But also check out some of the previous videos in the description about previous examples that basically talk about discoveries from the last few years. Hello info person, this is Anton, and today we're going to discuss one of the more unusual supernova remnants discovered in the Milky Way galaxy that up until a few years ago remained completely mysterious. But completely by accident, just over a decade ago, an amateur astronomer discovered the remnant looking for something entirely different, in the process helping us solve several mysteries, but also helping us discover potentially one of the more unique supernova we've discovered so far, and a supernova remnant that actually started unusual emissions just over 20 years ago. And so let's talk about this a little bit more, but let's also start with ancient history that helped us identify where to even look for this particular supernova by looking at some of the more ancient texts from Japan and China. And this is technically now becoming a kind of a new field in astronomy that's sometimes referred to as astronomical archaeology or archaeoastronomy. which in essence focuses on various archaeological findings in order to discover how the night skies were different back in the days, or in order to identify very powerful events such as nova and supernova. And back in the days, in ancient China and even in ancient Japan, quite a lot of astrologists were able to directly pinpoint the appearance of these so-called guest stars that would exist in the night skies for a few months and would then disappear into nothingness. And today we know that these were very likely very powerful nova or supernova in the Milky Way galaxy. And as of 2024, 5 such supernova have been confidently identified by using some of these ancient texts and then comparing them to various remnants we do see in the night skies. And so in 1181 AD, several astronomers, or I guess astrologists, mostly because in ancient China and in ancient Japan their job was actually to use the stars to predict the future, detected a new guest star. A star that appeared to be just as bright as Saturn and existed in the night skies for approximately 180 days. And based on 8 separate texts from China and from Japan, it was tracked to the location you see right here to a potential remnant known as 3C58, which just happened to be a pretty well-known pulsar and was definitely a supernova remnant located about 10,000 light years away from planet Earth. But here there was a small problem. Based on radio and X-ray observations, this pulsar was spinning approximately 15 times per second, and that was maybe a little bit too fast compared to what it should be spinning after 1,000 years. For example, the iconic crab pulsar, which was formed around the same time, was spinning much slower. And that's because we expect these neutron stars to lose up to 2/3 of their rotational power over a 1,000-year period. Furthermore, additional observations possibly established that this was actually much older, very likely at least 3,500 years old, making this supernova remnant very bizarre compared to what's expected based on its age. And so the mystery here was that, despite the location, this remnant might have actually been incorrect. As in, this was a supernova from some times ago, but was not the one we're looking for. And then, completely by accident, in 2013, Dana Patrick, an amateur American astronomer, discovered this. At first this was only seen in the infrared light, but was surprisingly in a very similar location. Now he was actually not looking for supernova remnants, he was looking for planetary nebula. But to his surprise, the 30th object he's ever discovered, the object now referred to as PA30, turned out to be that supernova remnant we were looking for this whole time. And at first it appeared as a very bright infrared orb that seemed to be extremely faint in optical light. But eventually the X-ray examinations discovered additional properties with visible shock waves and also unusual tendrils that are actually kind of mysterious, and we've discussed them in one of the videos in the description. But most importantly, right in the middle, there was something super hot with extremely powerful stellar wind. The wind that was expanding at 16,000 kilometers per second. And the wind that was mostly made out of carbon, oxygen, and neon. No hydrogen, no helium. Which essentially suggested that this was an unusual white dwarf. And that possibly did not make sense at first. But it was confirmed to be a white dwarf, and was also confirmed to be possibly the hottest star in the Milky Way, approximately 200,000 Kelvin. And so because of these very bizarre observations, it suggested that this is a unique object, possibly even an object we've never really seen before. And eventually it was established to be some kind of a super heavy white dwarf, possibly heavier than a typical white dwarf should be, so basically over 1.4 solar masses, and a white dwarf surrounded by various filaments, very powerful stellar wind, and a lot of other bizarre structures. But most importantly, the actual age and the location matched the observations from ancient Japan and ancient China. And so this was indeed the supernova we've been looking for this whole time. But what exactly formed this, and what exactly are we looking at? Well, it turns out that this is probably the result of an extremely rare event, sometimes known as Type 1ax supernova, where two slightly different white dwarfs collide, leaving behind a single supermassive, rapidly spinning white dwarf that seems to produce a lot of very powerful emissions. And though typically we expect these white dwarfs to be destroyed producing a supernova, there is a supernova, but there's also what's known as a zombie star left behind. And by itself this is maybe not as unusual as it sounds. We know that the Milky Way galaxy has a lot of binary stars, and most of these binary stars are not so different from our Sun and from a lot of different red dwarfs. a lot of these stars eventually become white dwarfs, thus producing binary white dwarf systems. And as these white dwarfs orbit each other, they start producing gravitational waves that slowly make them come closer and closer and eventually merge. But in the majority of cases, this merger just produces a very powerful explosion, most likely leaving nothing behind. But it looks like in some cases, extremely rare cases, a merger of a carbon-oxygen white dwarf with an oxygen-neon white dwarf produces a very powerful remnant shell and a supermassive white dwarf. And also a white dwarf with some really extreme properties. For example, a lot of this is actually powered by residual radioactive decay from, for example, isotopes of nickel. And though normally some of these isotopes have a typical half-life of about several days, in these extreme environments, a lot of these isotopes become ionized, preventing them from decaying for hundreds and hundreds of years, which essentially forms an extremely powerful object with a lot of powerful emissions, lots of heat, lots of radiation, and extremely powerful stellar winds. But it's really some of these recent discoveries from the research you can find in a description that basically makes the star even stranger. Here the team discovered that a lot of these super powerful emissions actually only started 20 to 30 years ago. With all of this discovered in the X-rays, by looking at this remnant, because this remnant contained unusual layers, suggesting several emissions over time. And so by creating a computer simulation to try to explain this, which was actually done just to understand why this unusual white dwarf was produced, here the researchers discovered that a lot of this stellar wind seemed to be kind of variable. In other words, the white dwarf was not always as powerful and was not always emitting so much powerful radiation. But most importantly, these observations would only make sense if a lot of this powerful stellar wind only began sometimes in the 1990s or basically 20 to 30 years ago, which by itself is very surprising, but also suggests something really important. This white dwarf is still quite active and seems to still possess some kind of a nuclear reaction that produces all of this. In other words, this white dwarf is still burning, which by itself makes it not a white dwarf already, and some kind of a very peculiar star we've never seen before. And so basically, the only way to explain these unusual double X-ray shockwaves is to have these emissions start sometimes 20 to 30 years ago or 800 years after the supernova. And the only thing that makes sense right now is some kind of a carbon burning which seems to have started as a result of a contraction of the white dwarf where the oxygen neon core starts to burn carbon inside. And if the scientists here are correct, this actually presents us with even more questions and also potentially some really important discoveries. For example, for all we know, this is going to go supernova again and possibly in the near future. Likewise, this is maybe not even a white dwarf and instead is some kind of a hybrid star that seems to still produce very powerful emissions and has a type of a nuclear reaction we don't really associate with white dwarfs. And so because of this, the scientists are now trying to investigate this using other frequencies and are hoping to now use Very Large Array Telescope along with the Subaru telescope to try to learn more about this unusual object. Either way though, whatever is inside this bubble seems to be very unique, very unusual, possesses properties we've never seen before anywhere, and most importantly, seems to be very unpredictable and for all we know could actually go supernova, maybe even in our lifetimes. I mean, assuming the scientists here are correct and these emissions started only 30 years ago, here we don't even know how long this is going to last and what's going to happen to this object afterwards once it runs out of material. Now normally, in a more massive star, this carbon burning process takes approximately 600 years to maybe 1000 years in total. And so in this case, for a much smaller star, we have no idea how long this is going to take, but it's probably going to be much shorter, possibly even just decades, which basically means that it might actually have just a few decades left before something else changes. And so for all we know, maybe we could witness a supernova in the Milky Way after all in our lifetimes. But that's of course just speculation for now. The supernova here is probably still going to happen, mostly because this is a supermassive white dwarf, but at this point it's not assumed to happen anytime soon. Either way, I'm sure in the next few years we'll hear more about this, because this object is definitely super mysterious and is one of the more anomalous objects in the entire Milky Way galaxy. Not to mention, obviously, the hottest and producing some of the most powerful stellar winds in the vicinity of planet Earth. And today we're going to discuss another really mysterious object that a lot of astronomers still have trouble explaining. And in this case, I think it's best if I show you the images of these objects first. Here's what they kind of look like in the infrared, visible by the Spitzer Space Telescope. And here's one of many such objects discovered in the famous Orion Nebula. Although one of the most recent studies on these objects was actually studying this. And so, hello wonderful person, this is Anton, and today we're going to discuss the unusual mystery of these very bizarre objects that today are referred to as proplyds, which is actually short for protoplanetary disk. But in this case, it's actually extremely different from a typical disk because of the unusual cometary shape they form. And the thing is, astronomers have known about these objects for several decades, but initially for the first couple of decades, nobody actually knew what's going on here, and scientists assumed that maybe these were just some unusual nebula. But then, in the mid-90s, the iconic Hubble Space Telescope was finally able to resolve one of them around a star system known as Theta 1 Orionis C. This is also in the Orion Nebula, and is basically an extremely bright and very powerful O-type star that produces a ridiculous amount of light. It's about 200,000 times brighter than the Sun, and as a result it also produces a lot of UV light, which usually ionizes pretty much everything in the vicinity. And so when this unusual star was analyzed even more, scientists discovered quite a few of these very bizarre cometary objects around it. But in every single case, the cometary tail was pretty much in the opposite direction from the star, which kind of gave us a hint on what's possibly happening here. Because these were such powerful stars, they were basically producing so much UV light that they essentially started to evaporate nearby star systems, producing a kind of a shock wave that would heat up the surface because of the UV light, warming up the gas and the dust inside the disk, expanding the disk in a process, and then basically dragging everything away through powerful streams of ultraviolet radiation. And so in essence, every one of these proplyds was a kind of an ionized protoplanetary disk, with the disk itself being evaporated by a very powerful star somewhere nearby, which basically made them resemble these unusual cometary objects. And today, approximately 180 of these are known inside the Orion Nebula, and we actually know the most in this nebula because it's basically the closest such object to planet Earth. But they also have been discovered in a lot of other nebula, and some even exist extremely close to the galactic center, very close to Sagittarius A star, but sometimes they're actually different types. As a matter of fact, they usually come in at least two different types. Some of them, the ones that are super close to these really bright stars, end up glowing themselves because of the star's luminosity. And this of course also makes them much easier to see. These were actually the first ones discovered ever, just because they produce these unusual glowing nebula. But other ones, the ones that are much farther away, usually show up as much darker objects and are very often extremely difficult to see. But it's these really bright ones that are particularly interesting. Mostly because it suggests that they actually evaporate gas here super fast. As a matter of fact, it looks like these baby stars are losing mass so fast that they technically would not even have any planets left after all of this is finished. Here's roughly what a typical structure of these objects usually looks like. And so in this recent study, the scientists actually wanted to do a much more thorough investigation of the object right here, specifically focusing on how much mass it loses in order to solve an unusual mystery about these objects. They technically should not actually exist. And that's because, based on the observations of the age of the Orion belt, we know that it's at least 2 million years old. But if all of this gas was being evaporated that long, it should have been gone a long time ago. And so here they wanted to calculate, so how much gas and how much dust is being evaporated inside this object. And so by using modern observations, using multi-unit spectroscopic explorer, on top of the very large telescope in Chile, they discovered the mass loss of approximately 1.07 times 10 to the power of minus 7 solar masses, which is equivalent to about 10 millionth the mass of the Sun. And that's every single year. But if this has been happening for 2 million years, should have already been gone. As a matter of fact, all of these proplyds should have been gone a long time ago. Yet we actually see quite a lot of them in the Orion Nebula, and a lot of other nebula as well. And then there is also the question of what actually happens at the end? Do these star systems end up with basically nothing, no planets and not even asteroids? Or can they still form something? Right now the observations and the calculations suggest that at the end there should be really no planetesimals in the system, with a lot of these stars basically remaining alone. And that's because most of these stars that are approximately 1 light year away from an extremely bright star end up losing pretty much most of the dust, at least according to some of these models. And interestingly, even the tail here is almost 1 light year long as well. So this is actually a lot of dust and a lot of material. But it's really the mystery of why they're even there. That's actually really what we can't answer. If they've been evaporating this material for a very long time, they should have been gone a long time ago, possibly within just a few 100,000 years. Yet we don't actually see anything like this in the Orion Nebula, and we don't even see these barren stars anywhere. And so even by analyzing 12 different droplets in this study, the ones that do contain cometary tails and the ones that are losing a lot of mass, the researchers still basically found no answer. There's still no explanation for why they haven't been destroyed, and there's also no explanation for why we don't seem to observe the end stage of this particular phenomenon. And despite this phenomenon being relatively rare, with most droplets just resembling something like this, the ones that do resemble comets are obviously a lot more intriguing. Mostly because we have no idea how all of this influences the evolution of material around these stars, and what all of this then turns into. And because these powerful stars, surrounded by much smaller stars with protoplanetary disks, seem to be actually pretty much all over the place, all of this very likely results in dramatic changes to a lot of star systems. But what exactly these changes are, nobody currently knows. For example, maybe one of the reasons we don't seem to find so many planets around certain stars is actually because they kind of survived this particular process with only a very small disk left at the end. Although obviously this still doesn't answer the question why these objects are still even here, even after possibly millions of years. I mean, maybe this implies that they actually started with much bigger disks, or maybe they're just passing by this star system with a relatively large velocity, and so they only get to experience this for a brief period of time. And so, in a nutshell, there's just no answer yet. But these are still quite mysterious and quite unusual, and definitely have to be studied in order to understand how various planets form around various star systems. Hello wonderful person, this is Anton, and today, once again, we're going to discuss some of the new studies about our friend Betelgeuse. Betelgeuse. Nope, still hasn't appeared. Anyway, so yeah, that supergiant star that surprised everyone back in 2019 when it decided to suddenly start dimming by quite a lot. And this lasted for several months, eventually becoming known as the Great Dimming Event. And even though additional observations have now concluded that it's extremely unlikely that this was signs of some kind of a upcoming supernova, and was most likely the result of some kind of a dust cloud emitted by the star, because a lot of the details are still murky, and because there have been several other studies in the last 3 years discussing additional propositions, we're essentially stuck with a bit of a mystery. Why exactly did this happen? And just recently, like a few days ago, there's been another study, another super interesting and very intriguing proposition that, in essence, suggests that Betelgeuse may not be just a single star and potentially does have a partner that we just cannot see. And if correct, this would actually change quite a lot about Betelgeuse, but would also explain so many things we've observed in the last few decades. And so let's discuss this in a little bit more detail, but let's also briefly discuss some of the recent propositions that have not been proven yet, but do present us with a somewhat intriguing scenario. For example, in one of the previous videos, with the links for these videos in the description below, researchers essentially try to figure out, is Betelgeuse going to go supernova soon, or is it possibly not going to go supernova for a very long time? And surprisingly, there were actually so many different, very solid explanations that all produced pretty much opposite results. For example, some studies suggested that this star was a result of a collision of two separate stars, which would explain why it's spinning so fast, and may actually stay the same and not change much for a very long time, much longer than we initially thought. Whereas other studies ended up with opposite conclusions. One of the most recent studies actually suggested that it might even go supernova within the next few decades, maximum several hundred years. And this is actually based on something entirely different. So, as some of you may know, Betelgeuse, that you can kind of see right here in the infrared, like so many other stars, is a variable star. In other words, it does not have a constant brightness. And you can actually see this pretty easily by looking at freely available graph of its light curves that shows us how the brightness changes over a period of approximately 6 years. And that big dip in the middle, that's the great dimming. But you can see that even before the great dimming, it was actually going brighter and darker at least several times per year. And so these unusual cycles, even though they're not perfectly understood, can generally be predicted pretty well. But in the last few years, scientists realized something else. By looking at a much longer term, we can actually see another unusual pattern. Another cycle that's approximately 2100 days long, that's known as an LSP, a long secondary period. And today we know that quite a lot of giant stars seem to possess these LSPs in general. These are usually seen in many cool, very bright stars, such as red giant branch stars or RGBs, yellow hypergiants, and red supergiants, with many of them possessing cycles of anything from hundreds to sometimes thousands of days long, with approximately 30% of all large stars possessing these cycles. You can find out about all of this in one of the older papers that should be in the description. And today we believe that a lot of these cycles seem to suggest something extremely unusual about these stars, but the exact explanation is still not certain. What is certain though is that they do seem to end up in very unusual asymmetric planetary nebula, or supernova that are basically bilobal. And so in many of these stars, for some reason, they seem to contain that secondary pulsation that's usually approximately 10 times longer than the primary pulsation. Yet these LSPs, or long secondary periods, present us with a bit of a mystery. And the mystery here is that which of these cycles is really the primary cycle? Because that's actually really important. We know that as a lot of these stars become older and basically come closer to that transition to the supernova or some kind of a planetary nebula, their cycles usually grow longer and longer. And so knowing how long the actual primary cycle is super important, at least if you want to figure out what's going to happen to the star and when. And so for Betelgeuse, trying to understand what the primary cycle is obviously kind of important. Because if that primary cycle turns out to be that longer cycle that's about 2100 days long, it would actually suggest that Betelgeuse is much older. And based on the calculations for this LSP, researchers believe it might only have a few decades or maybe a couple of centuries left before it actually does go supernova, producing a really bright event, almost as bright as the full moon. And so in the last few years, the big question became, is that 2100-day cycle its fundamental mode? Is this the main variability cycle, suggesting that the star is much older? Because this would actually place the evolution of Betelgeuse beyond the onset of the carbon burning and implying that the supernova might be imminent. But if this is a secondary period, then it still very likely is burning helium and is thus unlikely to go supernova for several 100,000 years, possibly even up to 1,000,000 years. And so just to give you a super brief summary, here we had two propositions. One is that the primary node or the brightness variation was approximately 420 days long, suggesting Betelgeuse will probably survive for hundreds of thousands of years. And the second proposition was that the cycle was 2100 days, suggesting that Betelgeuse only had like a few decades left. With this proposition obviously being more exciting, just for the sakes of science and I guess fireworks, this one maybe not so exciting, but also a lot more likely. And so as a result, a lot of recent studies essentially focused on that main question. And so the most recent study potentially discovered one of the best explanations we have so far. Here, Jared Goldberg, Meredith Joyce, and Laszlo Molnar propose a body for Betelgeuse. Maybe there's actually a hidden partner that explains the secondary cycle and actually explains the great dimming as well, potentially covering all of the mysteries all at once, with the actual proposition being relatively simple. Betelgeuse might have a much smaller partner, maybe just a little bit more massive than our own Sun, that seems to orbit around it every 2100 days, in the process producing all sorts of effects. For example, the brightness variation involves a somewhat complex formation and removal of dust, usually along the line of sight from planet Earth. And once in a while, when this dust becomes clumped in certain ways, it might actually end up in one of the Lagrange points and gets expelled in such a way that it produces a much bigger dimming event, which is what they believe might have happened in 2019. Because according to their model, that event happened during the so-called LSP minimum, which is essentially when this partner, hypothetical partner, would be kind of pointing in the direction of planet Earth. But if this is so, why is it that we're actually not seeing anything? And where exactly is this star hiding? Well, the explanation to this is relatively simple as well. Betelgeuse is ridiculously bright. It's about 10,000 times brighter than the Sun. And so if the star here orbits with a period of 2100 days, it's actually just close enough to Betelgeuse where it's going to be practically invisible in most frequencies of light. And that's because this star would be very similar in brightness to our Sun, right next to an object that's about 10,000 times brighter. And so the only way we could ever see this is by maybe observing various changes in dust and radial velocity for at least several decades, which could then maybe show us that the dust here moves in a very specific way, circling around as if something is orbiting around the star. And so basically detecting the star, if it's just a regular star, would be very challenging. But if it's a white dwarf, or if it's maybe a neutron star, which is somewhat unlikely, but I guess could exist, we might be able to see certain variations in the X-rays, which as far as I know have not been detected yet. But assuming the age of Betelgeuse at 10 million years, and assuming two stars here formed at the same time, we can basically make some estimates about what's going on. So obviously the radius and mass of Betelgeuse don't really change much, but it now has a partner known as Orion b that's just a little bit more massive than the Sun, and is approximately 1850 radii of the Sun away from the center. So I guess it would be just a little bit farther away from the edge of Betelgeuse, not really touching it, but extremely close. This would be approximately 8.6 astronomical units away from the center. And if this hypothesis is correct, this could be some kind of a low-mass, pre-main sequence star that's still developing and potentially even has some kind of a protoplanetary disk. And obviously the disk here would be very likely extremely disturbed. It's the interaction between the disk and the dust from Betelgeuse that could possibly lead us to one day discover it. And so interestingly enough, right now this is the best explanation we have for this unusual 2100-day periodicity. Even though there are other explanations like, for example, giant cell convections, mode interactions, non-radial pulsations, or even unusual dust modulation, it's really the partner that seems to easily explain everything we've seen so far in the last 5 years pretty well. And obviously, if correct, it would also suggest that Betelgeuse, as mentioned before, is unlikely to go supernova anytime soon. It probably has at least a few 100,000 years left, and may even survive longer depending on what happens with the partner. But once it does go supernova, it's probably going to be very unique and produce an extremely unusual remnant, while also dramatically changing its partner, potentially turning it into a slightly different star. But obviously, for now at least, this is just a hypothesis and definitely needs a lot more evidence. So just a few days ago, from when I'm making this video, once again Earth experienced some of the most beautiful aurora we've seen in years. The result of major eruptions from the Sun and a coronal mass ejection that was produced in early October. And on October 3rd, 2024, the Sun essentially produced this. The most powerful solar flare of this solar cycle measured at X 9.05. And although not all solar flares result in coronal mass ejections and thus produce aurora, this one did. As a matter of fact, there is actually a bit of a confusion usually when it comes to differentiating between solar flares and coronal mass ejections. In a nutshell, a solar flare is a really bright flash that usually produces a lot of ultraviolet and even X-ray radiation, which travels at the speed of light and sometimes causes radial blackouts, while also affecting the upper atmosphere. In contrast, a coronal mass ejection is basically a burst of particles resulting from a snap of magnetic lines around the Sun, which travel much slower and usually take a few days to reach planet Earth. But when they do, they very often cause dramatic shifts in the magnetic lines of planet Earth, with a lot of these particles following the magnetic lines and then colliding with the atmosphere, producing various visual effects, which is basically what we call aurora. And that's essentially what many of you might have witnessed last week. And even though this was the most powerful solar flare in the last 2 decades, here I think we have to be super grateful to our Sun. And so, hello wonderful person, this is Anton. Let's talk about recent discoveries about solar flares, or technically stellar flares, and how ridiculously powerful they seem to be around other stars, and briefly discuss what this means for potential habitability of various planets around those stars. Although here I actually briefly wanted to mention one more thing. So yeah, this was the most powerful recent flare, but the most powerful flare ever seen on the Sun is actually this. This was in 2003 during the Halloween storms, and it was actually an X45 class solar storm, with the letter and a number indicating how strong the flare was. When it comes to flares, there are actually 5 categories: A, B, C, M, and X, with X being the most powerful. And the number in this case indicates the total amount of energy. So for an X10 class, that's a release of 10 to the power of 32 ergs of energy. And because this flare was X45, it essentially produced 4.5 times more energy. And so for the Sun, this is basically as powerful as it gets. In contrast, in the last few years, researchers have actually been able to identify several super flares coming from various stars out there. And just like a few days ago, one of them was even seen 1600 light years away from us in a star system HD 251108, where a giant star, approximately 7 times more massive than the Sun, was just observed by the X-ray telescope on top of the International Space Station. This is the nicer telescope, able to detect X-ray emissions from really far away. And while compared to the Sun, this emission was ridiculous. Once again, some of the larger flares on the Sun usually produce 10 to the power of 32 ergs. In contrast, this one was at least 100 times more powerful. And this flare was so powerful that its effects on the star were observed even after 10 days. And surprisingly, this is a typical flare for many different stars out there. And so in the last decade, scientists discovered many of these super flares around different types of stars. But there was one star that they actually wanted to learn more about: the M-type star, more commonly known as the red dwarf, which essentially represents the most common type of stars in the entire galaxy. But much more importantly, pretty much most of the terrestrial planets discovered so far are all orbiting red dwarfs. Some of the most exciting ones, including the ones in the habitable zones, all seem to be around M-type stars. And though generally speaking, they're obviously much smaller and much less massive than the Sun, and produce much less energy, they seem to be a little bit more dangerous for a lot of planets orbiting in their systems. And that's despite the fact that they actually burn hydrogen really slowly, which actually means they can survive for hundreds of billions of years. But it turns out that a lot of recent studies discovered that they also produce super powerful flares. Flares similar to the one we just observed 1600 light years away from us, and flares that we've even seen several times around some of the more famous nearby stars. And that actually includes the Proxima Centauri, the closest star to us, the one that actually does contain a terrestrial planet in the habitable zone. And so over the years, this basically raised the question: so what does this mean for this planet? Does it mean that it actually lacks any chance for habitability? And does it mean that it potentially has no atmosphere and obviously no chance for liquid water? And so that's essentially what this new paper tries to establish. The study by Vera Berger and her team takes a look at 182 flares from 158 nearby stars, analyzing their ultraviolet emissions. In the process discovering that, yeah, they actually seem to be even more dangerous than we initially thought, with the total energy potentially being miscalculated and the actual energy being even higher. And so in essence here, the researchers focused on approximately a decade worth of observations from telescopes like Galactic, examining approximately 300,000 stars and discovering 180 flares that came from red dwarfs. And because previous observations mostly focused on the optical light, here it was actually kind of difficult to establish how much ultraviolet emissions these flares actually produced. And knowing how much UV light was produced is technically super important. And that's because not having any UV light suggests that any planet here could potentially lack the ability to form things like the ozone layer. So basically, to form the ozone, we actually need to have some UV in order to break down oxygen molecules and to then produce ozone, which protects the planet from something more dangerous. Likewise, UV light also initiates certain important types of chemistry in the upper atmosphere. For example, the evolution of various proteins and enzymes was most likely the result of ultraviolet radiation, and the evolution of certain mechanisms inside DNA. In other words, in order to have a truly habitable planet and to potentially have life on it, you do need to have some UV radiation, but there is a limit. Too much radiation and too frequently will actually have the opposite effect. And so by having too many stellar flares, And by producing too much UV radiation, it can actually strip away the atmosphere of the planet in just a few million years. And so this recent study essentially discovered that many previous studies potentially underestimated the amount of UV light produced by various flares. Here we're talking about flares around distant stars. And so 180 flares discovered in this study very likely had at least 100% more emissions compared to previous calculations. And that of course suggests that planets around those stars would be most likely stripped of atmospheres really quickly. Many of these planets would very likely be hostile to life and even incapable of maintaining atmospheres. And that's even for planets in so-called habitable zones. And because in many of these cases, these planets are also much closer to the star, with a typical orbit of just 7 to 10 days, this would also dramatically increase the total amount of radiation received on the surface. And so many of these objects would be basically stripped entirely in under a million years. And that's a really big difference from what was previously discovered approximately 4 years ago. In one of the previous studies, by looking at approximately 1200 flares, researchers only discovered approximately 8% of stars producing powerful enough flares to potentially cause ozone depletion, with only 1% of stars possibly stripping planets of everything on the surface. But here the study suggests otherwise. A lot of these flares were potentially much more powerful, thus producing way more energetic UV light, and the UV light that would not be productive for life and would instead destroy it. In contrast, for our Sun, the UVC radiation is actually perfect for driving prebiotic chemistry, while also being responsible for the ozone layer, which once again implies that our Sun just kind of seems to be perfect. It's essentially in its own Goldilocks zone, where it produces just enough UV light to be extremely useful for life, but not enough UV light and not enough flares to become overly destructive. And that of course means that discovering some kind of a star system that's going to have similar conditions might have just gotten a little bit more difficult. It looks like many stars, especially red dwarfs, potentially produce too many flares, and many of these flares would not be conductive for life and would instead destroy planetary surfaces, leaving no atmosphere and no chance for water to exist. But that's of course just based on observations from those 180 flares. In order to understand how all of this works, and in order to find out if any of the planets out there can potentially have similar conditions to planet Earth, we obviously have to have a much bigger sample. And so in the next few months, or possibly in the next few years, we might discover additional details about star systems like the TRAPPIST-1 system, with its 7 terrestrial planets in orbit, that could potentially help us understand if anything can exist there. Right now, based on the observations from the James Webb, we know that the 2 nearby planets seem to have nothing. They've been stripped entirely of any atmosphere, and so at the moment it doesn't really look good. But there are still 5 planets to go, and so once we get some updates or some new discoveries about those planets, we'll come back and talk more about this in some of the future videos. Hello wonderful person, this is Anton, and today we're going to discuss the idea of Dyson spheres, the hypothetical superstructures that some astronomers believe could be built by advanced civilizations out there in order to harvest as much energy from the star as possible. And though naturally this is still a super hypothetical proposition with practically no evidence as of today, right now we're going to discuss 2 studies that just came out that actually do find something somewhat intriguing. Surprisingly, there are stars out there that potentially show signs of something unusual, and we're not sure what. And so let's discuss this idea, but I guess first, in case you've never heard of Dyson spheres, what are they? Well, this is actually mostly an idea that stems from a relatively old science fiction story, Star Maker, the book that explores the future of humanity for 2 billion years, with one of the propositions in the book being an unusual structure that would harvest the energy of the star directly. But even though this started as science fiction, a couple of decades later, in the 1960s, this was later explored by the British physicist James Dyson, who essentially wanted to explore this from a more scientific perspective. Wait, nope, that's the wrong guy. That's James Dyson, who invented the vacuum cleaner. I constantly make this mistake. Not this guy at all. It was not the vacuum cleaner physicist guy, it was the mathematician and the theoretical physicist British guy, Freeman Dyson. And so back in the 60s, he started to think about this scientifically and mathematically, and basically imagined some kind of a spacefaring civilization that would be able to harvest the star's resources directly by building individual structures orbiting the star. Technically, we would call this a Dyson swarm, not a Dyson sphere, because only a swarm would stay in a stable orbit with the sphere potentially breaking apart. All of this was explored in his 1960 paper, Search for Artificial Stellar Sources of Infrared Radiation. The study you can find in the description below. And though he didn't actually discuss how such a structure would be constructed, he talked about one thing: how such a structure could be detected. He basically proposed that such a megastructure is going to re-radiate a lot of energy in specific frequencies of infrared light, unusual for the star of the spectral type. Or in other words, if we actually see a G-type star like our Sun emitting extra energy in the infrared light, especially appearing different from any elements known inside the star, it could potentially mean that this is maybe a megastructure and not actually coming from around the star itself. And one of the most famous recent examples of such a detection was of course the famous TRAPPIST star, KIC 8462852. Here this was a detection of extra infrared energy along with an unusual dimming of 22% that was assumed to be maybe from some kind of a megastructure. Basically something covering the star, but further analysis and very thorough investigations in the last 9 years established that this is unlikely to be the case. A lot of the emissions here, and the dimming itself, appears to be very similar to a typical dust cloud. And so essentially some kind of a dust ring or some kind of a dust cloud in front of a star potentially explains both the infrared emissions and the unusual dimming. Mostly because the dust in this case would be glowing in infrared light. And so that's basically how these unusual superstructures are generally searched for today, by looking at infrared emissions that should not be there, making this a very unique technosignature. But now we have a really intriguing pair of studies that basically analyzed millions of stars using different surveys, making some intriguing discoveries, with both studies conducted by two separate teams and actually using slightly different surveys and slightly different data, but based on a lot of really good data from, for example, Gaia telescope that tracks the motion of stars, and also slightly older surveys such as 2MASS and the surveys by the WISE telescope that provides infrared data. And so by combining the motion of stars with the infrared data, and by analyzing approximately 5 million stars, both teams discovered very strange candidates. For example, in that first paper, they discovered 7 red dwarfs within approximately 900 light-years of planet Earth, and here we're talking about very common stars in the galaxy, and basically stars that usually contain terrestrial planets, that appear to be up to 60 times brighter in the infrared light compared to what they should be. And 60 times brighter is no joke. And if this excess of brightness is caused by some kind of a superstructure, here the analysis suggests a temperature of about 25 degrees Celsius, to some extent consistent with various predictions about Dyson swarms and Dyson spheres. But because the stars themselves are visible, this is definitely not a Dyson sphere at all, and has to be a Dyson swarm that can only hide up to about 16% of the entire star. So here this would suggest some kind of a orbiting superstructure consisting of a large amount of satellites. And then the second team focused on slightly different stars and conducted a different analysis, discovering 53 candidates, including a lot of larger stars, some even similar to our Sun. But here the distance was up to 6,500 light-years, so many of these objects were much farther away. And some of these candidates were basically the same. And so does this mean we actually found signs of Dyson spheres? Well, just like with the TRAPPIST star, not really. Unfortunately, this is just a super preliminary result and is more likely to be actually the case for something strange going on with these stars as opposed to being a superstructure. And no, this is not me being super skeptical, these are the actual conclusions from both papers. Every single one of these discoveries would have to be followed up with telescopes like the James Webb, but so far all of them do have natural explanations. For example, they could just contain some kind of a hot planetary disk that produces extra emissions. And though most of the stars discovered here are kind of old for this and should not contain these disks, it is still quite possible. Likewise, it is quite possible that some of these stars are actually aligned with a separate object in the same vicinity, for example a distant galaxy, that's technically extremely close to the star and is responsible for this extra infrared light. So basically there could be something photobombing the star, and we just were not seeing what just yet. Also, maybe some of these stars have this, possibly showing signs of major collisions in the star system that do actually produce extra heat. We've actually discussed one of these detections very recently in one of the videos in the description. Or maybe these stars are just very unusual for other reasons. Maybe they have some kind of an unusual reaction on the surface, or maybe they combine with something like a planet that changed their overall brightness and their infrared emissions. Either way though, right now the conclusion is that it's very likely natural and not extraterrestrial intelligence. Nevertheless though, this is definitely going to require additional studies and hopefully observations with the James Webb and potentially SETI telescopes. Every one of these 50-something stars is still obviously a candidate for some kind of an extraterrestrial intelligence and still has to be explored in order to explain what's going on there. I mean, for all we know, maybe someone's actually trying to move the star by using what's known as a Shkadov thruster, or basically a bunch of satellites around the star in just the right position that forces the star to create a momentum moving the entire star system somewhere else. But yeah, chances of that are possibly not very high. Either way though, we'll definitely come back and talk more about this once there are some additional observations and possibly something else is discovered, because as of I guess 2024, these are some of the most exciting candidates for potential signs of some kind of a technosignature somewhere out there. Definitely great discoveries, but it'll probably take months to see what's up. Right now, unfortunately, this is very preliminary and there's really nothing else to add. We basically have a bunch of stars that are slightly hotter or produce extra infrared light compared to what we expected. Either way, if this is natural or not, it's going to lead to some incredible new discoveries. Today I wanted to discuss some of the recent discoveries and I guess some of the recent mysteries coming from a very famous star. The star you see right here. This is Vega, one of the brightest stars in the night skies. It's approximately twice as massive as the Sun and is about 700 million years old. And so when it comes to this star, some of the most recent observations reveal something nobody expected. And in this case, it's not something that we found. It's actually something that we didn't find, and something that was expected. And so, hello info person, this is Anton. Today, let's talk about Vega and discuss the idea behind why Vega does not seem to contain any planets. Even though technically it should, and even though technically we expect planets around most stars. But here I wanted to start with a really brief video clip from the iconic movie Contact. This is Jodie Foster's character, somewhere near the end of the movie, where she basically goes to Vega. And that's because that's where the aliens in this movie are from. And so in this movie, Ellie Airway goes through a wormhole and arrives to Vega to basically discover an enormous amount of debris everywhere and, surprisingly, no planets. And this is really bizarre because it turns out that this is exactly what's possibly happening in real life as well. So completely by accident, this movie was able to predict this several decades before we actually got to observe the star. But I guess here let's start with the basics. So this is how the star compares to the Sun. Approximately twice as large, approximately twice as massive, also twice as hot, but contains a little bit less metallicity or basically heavier elements, and also much younger. It's most likely about 700 million years old compared to approximately 4.5 billion years old for the Sun. But this is not a baby star and it's already quite developed. And so as a result, not only do we expect it to contain planets, we also expect it to not really contain any kind of a planetary disk. But a while back, in 1984, the observations from the first infrared telescope, IRAS, discovered unusual infrared signatures coming from both Vega and its unusual twin, Fomalhaut. These are two very similar stars, very similar in mass, similar in brightness, and even similar in age, that are also very close to us and are also just as bright. And so here the idea was that maybe these two stars contain some kind of a really large asteroid belt or even something similar to the Kuiper belt, suggesting some kind of a leftover from previous periods of planetary formation. And when it comes to this planetary formation, telescopes like ALMA discovered an enormous amount of protoplanetary disks that all showed very similar features, and even signs of early planets, usually visible as tiny gaps between the disks. And in some cases, even planets themselves were visible there as well. And so here it was assumed that Fomalhaut and Vega would essentially contain large planets, but also some kind of a leftover or debris from an ancient disk. Something that resembles the asteroid belt but something that's just much bigger. And that's of course based on a lot of different assumptions from the 90s and early 2000s, where scientists believe that most planets very likely form in a very similar way. But back then we also made a really wrong assumption about something else. We actually assumed that most star systems would have very similar planets to what we have in the solar system. So basically a few gas giants, some rocky planets, some Neptune-like worlds, and of course the asteroid belt. Yet within the last 2 decades, that view has been proven to be incorrect. In reality, every single star system seems to be more or less unique and does contain a lot of really unusual planets. As a matter of fact, the most common planets are the ones that don't seem to exist in the solar system, so things like super-Earths and mini-Neptunes. But still, the assumption was that most stars should contain some planets, or at least stars containing enough metallicity, enough heavy elements to produce planets. And so if the metallicity of a star was over 25% of the Sun, it was expected to have something somewhere. Whereas if the metallicity was very low, below 8%, it was maybe expected to have either nothing or something similar to a brown dwarf or your typical Jupiter, but maybe no terrestrial planets. And well, in the last few years, we did have quite a few observations of the famous Fomalhaut hole. Here the disk was so easily visible that lots of different observations revealed some intriguing structures. But it was of course the recent observations from the James Webb that were most exciting. Here we finally had additional proof of actual planets and very large dust disks that were previously observed with older infrared telescopes. Here we basically observed several massive asteroid belts extending all the way to the outer reaches of the star system, 210 AU from the star, and at least one planet, definitively confirmed, now referred to as Dagon. This planet was at least 3 times as massive as Jupiter, and basically showed us that a lot of these disks, really massive disks, are extremely likely to form really massive planets. Which is of course something that was now expected from Vega as well. And that's because these 2 stars are super similar. They both seem to exhibit these infrared signatures. As I mentioned, they both seem to have very similar mass, very similar brightness, and very similar age. But for years now, the Hubble Space Telescope was struggling to discover anything. Here, several observations by the Hubble captured the outer halo disk, basically discovering a lot of small particles that seem to be no bigger than what you usually find in smoke, which meant that there was something missing. And so new observations with the James Webb finally gave us a new perspective. And here's what this unusual image looks like. Here we finally got to see additional types of particles inside this unusual debris disk. But intriguingly, the first thing that stands out is that there doesn't seem to be enough evidence for any large planet. Definitely nothing similar to what we observe in other star systems, and definitely different from Fomalhaut or any other developed systems that are at least a few 100 million years old in age. And so here both Hubble and the Webb presented us with a very unusual view of Vega. This was a bizarre circumstellar disk like we've never seen before. It was surprisingly smooth, surprisingly symmetrical, and seemed to contain almost nothing that resembled a planet. Although in this image from the Webb, you might notice that there is a bit of a ring in the middle. And so this very small gap might suggest that there could be something, possibly something very small, only a few masses of planet Earth in mass, at 60 AU away from the star, and what's more, both telescopes reveal something else unexpected. They basically reveal an unusual dust distribution that produces layers that can only be created by the pressure from starlight for millions and millions of years. And that's because starlight pushes away smaller grains much easier than heavy grains. And so here what we get is a lot of bigger grains on the inside and a lot of smaller grains on the outskirts. And that's exactly what we see with both telescopes. Small grains far away, large grains inside. But once again, no signs of any planetary mass similar to a typical gas giant, or even similar to Neptune. Here there seems to be no planets more massive than at least 6 masses of planet Earth. And that's completely unexpected. Mostly because this is a really massive disk, and previous assumptions were that these disks should be forming planets left and right. Yet because we see nothing, it suggests that there is a mystery in regards to planetary formation that we just cannot answer yet. In other words, our previous assumptions are once again kind of incorrect. And this was confirmed by conducting additional simulations, trying to see what would happen if there was a planet. And so if there was anything really massive, the disk would look entirely different. And so the only way we can explain what's observed here is if we have either no planets or really small planets, similar to planet Earth, but orbiting on the outskirts. In other words, this is just a really bizarre system nobody expected to discover. Or maybe this is not bizarre at all and is actually really common, but we just cannot explain why this star system is the way it is. And interestingly, one major difference between this system and the solar system is just the fact that the dust here is so spread out and so far away. In the solar system, Jupiter and Saturn are basically keeping the dust at bay and usually prevent this dust from moving so far away and, more importantly, from becoming so smooth. And though obviously there is some dust here and there, usually the result of asteroid collisions or even emissions from Mars, something we usually refer to as zodiacal light, you can learn about in one of the videos in the description. In Vega, the fact that the ring is so smooth and so big confirms there are no giant planets, and possibly no planets that are massive enough to influence anything. And that's after 700 million years. Entirely different from Fomalhaut, which seems to contain giant planets, and the disk is entirely different too. As a matter of fact, Fomalhaut has at least 3 different belts with very distinct features. Here, this is all really smooth and very spread out. It's basically just one large disk. Now, because this star is at least 30% metallicity of the Sun, we've always expected some planets here that would have been discovered eventually. Yet right now, as of 2024, we only had hints of planets here and there. Actually, one hint is from a paper right here by Spencer Hurt and his team that believe they discovered a planet with a very short period of 2.4 days orbiting really close to the star. But despite these initial hints, right now there is really no evidence for anything. All of the previous planetary assumptions so far resulted in nothing. And all of the recent papers from just the last few months could not confirm the existence of any planets in any part of the system, making Vega a really strange exception to the rule. Or is this a rule? Basically, this is something we assumed before, but we might have been completely incorrect. Maybe some stars just don't have planets and cannot form them at all for reasons we still don't understand. And since typical star systems are expected to have planets in the first 10 million years, if a star system has not formed planets after 700 million years, here we really have no idea how to explain any of this. And more importantly, this disk did not disappear with time like it does in other star systems. It's basically present as if the star is still a baby. And so instead, what we seem to observe is a very unusual, very cold outer belt, which appears to be very similar to the Kuiper belt in the solar system, but extending over much larger regions. But as you can see right here, there's also a much warmer inner disk, which is kind of similar to the asteroid belt, but once again, much larger in size. As a matter of fact, here, it's bigger than the entire solar system. And while in pretty much all other star systems, the presence of these two features usually means that with time they develop planets. Not here though. Something here is stopping everything. But as I mentioned, there might be a small planet somewhere, possibly even a terrestrial planet, because we do see this tiny gap. Although here, because it's so far away from the star, it's definitely not in the habitable zone, and so this planet would be super cold. Realistically though, we're not going to know exactly what's happening here for at least a few more years. Until additional observations from Vega or similar stars, we're not going to be able to answer the question of where are the planets. We're not going to know why the disk is still here, or why this disk is so ridiculously large and so smooth, and we're also not going to know why Fomalhaut, despite similarities, is so extremely different. It's just going to remain a mystery for at least a few more years. Hello InfoPerson, this is Anton, and today we're going to discuss a somewhat intriguing mystery in regards to missing stars, or technically stars that vanished. They used to be visible in some of the older data, and then suddenly disappeared. And we finally have at least one explanation with very good evidence coming from the Andromeda galaxy, possibly explaining what happened to some of them. But first, I guess, let's establish what the mystery here is. Here, this is based on a slightly older study we discussed in one of the videos in the description, a study that describes a project known as VASCO, Vanishing and Appearing Sources During a Century of Observations. A study that was based on observations from 1950s, comparing them to observations from today, where stars mysteriously vanished. And so here, based on very detailed observations from 150,000 different candidates, researchers definitively identified 798 objects, with the number actually going higher in one of the recent studies, that definitively disappeared without any trace and without any explanation. And intriguingly, one of the potential explanations that was kind of going around was that maybe these became Dyson spheres. In essence, this was a potential sign of possibly some kind of a Type 2 civilization covering the star and extracting its energy. But obviously that's a very far-fetched explanation, and so many different scientists try to figure out what else we can actually do here in order to discover what really happened. And while technically, to date, there is still no explanation for most of these disappearances. But a few months ago, there was actually one study that possibly explained the disappearance of some of these stars. And here the assumption was that many of these stars potentially just collapsed into black holes. But obviously this needed evidence. And that evidence was not very easy to discover. And so back in May of 2024, scientists potentially discovered first binary system with a black hole and a star, where the only explanation was that the star collapsed into a black hole in order to produce such a perfect star system. You can learn about this in one of the previous videos in the description, but this provided us with first piece of evidence that these collapsing stars could possibly exist. And interestingly, there might have been a previous suggestion that these objects exist from a slightly older observation back in 2014. This is actually the object you see right here. And so here several papers propose that we're observing what's known as a failed supernova. This was actually a supergiant red star, approximately 25 solar masses, that was part of the galaxy known as the Fireworks Galaxy. And it's actually called that because of constant supernova. But approximately a decade ago, this unusual object that was supposed to go supernova didn't. It completely disappeared, leaving behind a very faint infrared glow. And so at first it wasn't actually clear what's happening here, with most studies proposing that this was indeed a failed supernova. But unfortunately, the most recent observations from the James Webb seem to disagree. Here, the observations in the infrared seem to actually suggest that this is a merger of two stars that resulted in a very bright object in the middle. You can actually learn about this in one of the recent studies in the description, and so this was not the evidence for the failed supernova hypothesis, which unfortunately took us back to not really knowing how some of these stars vanish. But intriguingly, a much closer galaxy, the Andromeda galaxy, finally provided us with the best possible example, with the most recent study by De and his team exploring all of this in detail. And so here we had a hydrogen-depleted supergiant star that was technically supposed to create a core collapse supernova, usually referred to as Type 2. Here this is a star known as M31 2014 DS1, and for some reason back in 2014 it started to become extremely bright in the infrared light. And so for approximately 3 years, its luminosity was more or less the same. But then, between 2016 and 2019, it started to fade dramatically. And by 2023, it was practically invisible, not visible in the optical light or in the infrared. In essence, it seems to have completely vanished. And based on additional calculations, here the scientists determined that this used to be a star that was about 20 solar masses when it was just born, and was approximately 6.7 solar masses sometimes in 2012. And so in theory, this star should have actually exploded and potentially resulted in a neutron star. But it seems to have disappeared. And it also seems to have left an ejected dust shell, suggesting some kind of a small explosion or a miniature supernova. It's just there was no optical outburst, which is usually what happens with Type 2 supernova. And this of course suggests that, well, first of all, we might not actually understand supernova that well after all. In other words, there seem to be some exceptions to the rule. For example, the decline in luminosity for 3 years suggests that the star in this case was actually decreasing its nuclear reaction, which eventually led to some kind of a failure and some kind of a collapse. But the question is exactly what happened. And this study potentially provides one explanation. Today, based on all of the analysis of other supernova, we understand that generally, inside this really dense collapsing core, a lot of electrons and a lot of protons start to combine into neutrons and also produce an enormous amount of neutrinos. And this process of neutronization actually happens everywhere where there is some kind of fusion. That of course includes our Sun. But inside of these collapsing stars, the density increases so much that a burst of these neutrinos can carry up to about 10% of the entire star's mass in an enormous outburst referred to as a neutrino shock. And though most of the time, including actually right now as you're watching this video, neutrinos pass through us without really doing anything, when their density becomes super extreme, they can and do deposit energy, hitting everything around them, and of course generating a really large shock wave. And what looks like neutrino shock in this case could possibly explain what's happening. Usually, as this neutrino shock advances, it eventually reaches a stage when it kind of stops. This is referred to as the stalled shock. But in many cases, it then reaccelerates and continuously expels the outer layer of the supernova, eventually destroying the star and leaving behind just a tiny remnant. But in some cases, looks like it just stalls completely, with the entire shockwave eventually collapsing back. And so in this case, instead of having a supernova, we basically end up with just a tiny shockwave, but most of the mass then collapses back into a black hole, which is actually what the scientists believe happened here. In this case, the researchers believe that only about 2% of the material escaped to the outskirts, which is exactly what's visible today, but 98% of the mass, or about 6.5 solar masses, collapsed into a black hole directly. And so based on this model and based on this explanation, this could be an extremely common phenomenon that we've just never really seen before, or at least never really confirmed until now. And technically this could have also happened in the Fireworks galaxy as well, despite the observations from the James Webb suggesting otherwise. As a matter of fact, the survey of 27 separate galaxies by the Large Binocular Telescope revealed that 20 to 30% of stars that usually go supernova can potentially end up as these collapsing black holes, or as these failed supernova, in essence suggesting that this is a completely new type of an object, or a new type of a stellar finale, somewhat different from your typical supernova, and basically always producing a black hole. But this can only be proven and confirmed by using a multi-messenger approach, or basically by studying these in very different wavelengths. Here we're talking about infrared, optical, X-ray bands, and possibly even radio observations, just to actually see what's happening here, and if this is indeed how a lot of these stars seem to vanish. And so in a nutshell, the explanation for many of these vanishing stars, or at least some of those 790 stars that vanished previously, could be that they just became black holes in a very similar way to what we just witnessed in the Andromeda galaxy. And since we now have actual observations, it basically implies that any stars more massive than about 6.7 solar masses could in theory disappear completely, turning into black holes. No supernova necessary, and possibly leaving almost nothing behind. But obviously, this doesn't explain all of the stars, mostly because many of those stars were very likely much less massive, and so the disappearance of those other stars is still entirely unclear. On the other hand, we don't even expect so many stars to go supernova in the Milky Way, and so only a handful of these stars detected in the study previously could possibly be explained as failed supernova. In the last few years, I've made a few videos about this somewhat unusual mystery, the mystery of disappearing or vanishing stars. And though you can find all of these videos in the description below, in a nutshell, they all discussed a very similar concept. Unusual disappearance of stars that used to be visible with older telescopes, with some examples being very extreme. Like here we have an unusual constellation of 3 stars disappearing in under an hour. And as you can imagine, naturally these first discoveries created a bit of a mystery, or actually a really big mystery. A mystery of disappearing stars. And to date, over 1,000 such stars have been discovered, with all of them disappearing in the last few decades. In most cases, they were basically visible by some of the earlier advanced telescopes in the 50s and in the 60s, and could then be no longer visible in the telescopes today. And so, hello wonderful person, this is Anton. Today we're going to discuss this mystery once again, and potentially discuss one of the major resolutions or one of the major solutions. And though this might not explain all of the stars, it will definitely explain at least some of these disappearing objects. Although here it's also important to note that this is not the first such explanation. Not so long ago we've discussed another star that also disappeared in 2015, but it was then explained by the James Webb, with the video in the description talking about this a little bit more. In a nutshell though, this was just an unusual type of a supernova that did produce certain emissions, we just could not see them in certain frequencies. But because over 1,000 such objects have now been discovered, this is probably one of the most intriguing mysteries in the Milky Way. So what exactly is happening here? And more specifically, how can an entire constellation disappear like this? Not surprisingly, when this was initially announced, one of the first more unusual explanations involved Dyson spheres. And so basically here, maybe you were witnessing some kind of an advanced civilization suddenly covering the stars in order to use them as a major energy source. But these explanations were pretty quickly disregarded for one important reason. By design, Dyson spheres should still be emitting certain frequencies, especially infrared light. And this infrared light should be visible with telescopes like, for example, the James Webb. But the locations of these disappearing stars were not producing infrared light either, and were actually not producing anything. And so if not Dyson spheres, maybe the explanations here were much more mundane, with some studies suggesting that maybe this was just basically a problem with the telescope, and specifically maybe this was just accumulation of dust, or some kind of an artifact inside the lens. And though this might make sense for some of these observations that were only conducted once, there were a few stars that were observed by separate telescopes and were missing in all of them. And so this was not a universal explanation either. But the majority of scientists, and I guess the main consensus here, was that maybe this was actually some kind of an unusual phenomenon involving the end of life for these stars, where they basically transition into something else without your typical supernova stage, kind of similar to some of the most massive stars that sometimes just collapse directly into a black hole. And in this particular case, if a large star suddenly turns into a black hole, it can potentially leave nothing behind. And though this has never been directly observed, mostly because it's obviously very difficult to see, it kind of has been predicted before. And so could all of these stars just be gone because they all became black holes? And here we might have our first really intriguing evidence. The answer could potentially be yes. For the first time ever, we actually have direct evidence of at least one such black hole, very likely formed as a result of a direct collapse, without any supernova remnants, and without any disturbance in the entire star system, basically proving to us that black holes do indeed collapse from really massive stars, just like that, without any fanfare, without any announcements. And in order to understand what's happening here, we have to look at a star system discovered 2 years ago, an unusual system known as VFTS 243. This is in the Large Magellanic Cloud in the famous Tarantula Nebula. Now this nebula is really important because this is actually where we find some of the most massive stars ever seen. As a matter of fact, the record holder, the star that could be about 300 solar masses, is also in this nebula. That star is known as R136A1, and you can learn more about this in some of the videos in the description. And well, one of the main reasons this particular star system is so exciting is because by looking at this star, the researchers discovered something really intriguing. Here, by using something similar to a radial velocity method, where we usually find different planets, and by essentially looking at the star and observing slight red shifts and blue shifts of the star, the scientists discovered that something is orbiting here as well. But not a tiny planet, because the red shifts and the blue shifts were massive. Instead, this object was quite obviously orbited by some kind of an invisible, ultra-dense object. But because no additional emissions were produced, the only thing that would make sense here is a slightly distant black hole, and a really massive black hole. The black hole here is about 10 solar masses, whereas the star itself is approximately 25 solar masses, with the star just over 7 million years old. And though obviously we don't see the black hole, we see the star. And the orbital motion, or the red shifts and blue shifts, definitely tell us it has a really massive partner. But so far none of this is unusual. These binary systems exist everywhere, and this is kind of expected to be produced as the stars get older. As a matter of fact, even this star has a chance of becoming a black hole because it's relatively massive. And so this will probably eventually become a black hole binary. But there is something very strange about the star system based on the orbit. Unlike a lot of previous observations from other star systems, here it's quite apparent that this black hole seems to orbit around the star in a very circular manner. And because the star system is only a few million years old, this actually creates a bit of a problem for how exactly this black hole formed. Now, in a typical scenario, we obviously expect a star to go supernova and to eventually leave behind a remnant, such as a black hole or a neutron star. And in pretty much most of these cases, we also usually find a lot of gas and a supernova remnant, which can last for thousands and thousands of years. We've actually recently discussed some of the most famous ones in the Milky Way galaxy, with several exciting discoveries you can learn more about in one of the videos in the description. But in this case, first of all, there was obviously no supernova remnant, but more intriguingly, the orbit was almost perfectly circular. And that's very unusual because in most cases, when a star goes supernova, it's never really perfect and it's usually extremely chaotic. As the star explodes and as it forms this huge cloud expanding in every direction, it's pretty much always a little bit one-sided. It's never really symmetrical. And as a result of this asymmetry, it usually produces what the scientists refer to as a natal kick. Or basically the neutron star or the black hole produced by the supernova acquires a vector of velocity in a certain direction, which by itself is usually really random and can even be really high. Here's actually one of the more extreme examples. These are known as cannonball pulsars, or essentially neutron stars that received such a huge natal kick that they actually started to move through their supernova remnant at very high velocities, almost resembling some kind of a comet. And in some cases they actually move at really high velocities, up to several thousand kilometers per second. But that's of course the extreme case. In a typical case, they still get some kind of a kick, but this just usually results in their orbit becoming a lot more eccentric and a lot more extreme. And this is basically how we usually get so many X-ray binaries, or basically various black holes consuming a lot of mass from their partner star and releasing all of this as powerful energy visible in the X-rays. And so a typical supernova is usually going to result in at least some kind of a natal kick. Yet strangely enough, in this particular star system, even though it's kind of young, it seems to show no signs of such a kick or no signs of supernova remnant either. And though at first this was a bit of a speculation, it has now been officially confirmed by several studies and presents a kind of a really intriguing mystery, or potentially a major solution. Because the main explanation now suggests that this is actually a result of a direct collapse without a supernova and without any other transitional stages. And so here what we seem to have is a relatively massive star basically instantly becoming a black hole, disappearing from the night skies without any announcements. With the implication from the study being that this is exactly what happened in these vanishing stars discovered back in 2019, and maybe black hole formation is a lot more diverse and more mysterious than we ever believed. Now obviously why this happens nobody knows. I mean, it could be some kind of a failed supernova, or maybe this is a mechanism that we've never really explored before, but because black hole collapse was previously proposed by other studies, having this evidence is really important. Although obviously here, to make this official, we would obviously have to find more similar objects and more evidence that this is widespread. And because these black holes would also not really emit a lot of light, remaining rogue black holes traveling across the Milky Way galaxy, at the moment there is unfortunately no way for us to directly detect these and to confirm if this is what happened to those stars. But by finding similar binaries to this one, with perfect orbits and without signs of supernova, we might actually have more evidence that this is exactly what happened here. And so yeah, unfortunately, not aliens, not unusual physics or some unexplained phenomena, but possibly just more black holes, which suggests that black holes might actually even be more common than we ever thought. But we'll definitely come back and talk more about this once there are some additional discoveries, because this mystery is super intriguing. I mean, here we're talking about over 1,000 stars disappearing from the Milky Way galaxy, with currently no actual explanation everyone accepts. But looks like this one might be the one that a lot of scientists are going to be leaning toward, just because we finally have that one piece of evidence. Hello wonderful person, this is Anton, and today we're going to discuss TRAPPIST-1 system once again, focusing on some of the most recent discoveries and some of the most recent studies, which essentially are all trying to answer the same question. Out of these 7 terrestrial planets, can any of them potentially host atmosphere and liquid water, and can any of them potentially host life? But as you might have learned from some of the previous videos from the past 2 days, based on a lot of recent observations, including the James Webb Space Telescope observations, one of the main conclusions so far has been that there is a very high chance that a lot of these planets are potentially entirely barren. This essentially could be some kind of a collection of really hot, dry rocks, basically containing nothing on their surface. Or at least these were some of the preliminary discoveries based on the observations from the TRAPPIST-1b and TRAPPIST-1c. And because stars like TRAPPIST-1, which are of course known as the M-type stars or red dwarfs, essentially make up something like 75% of all stars in our galaxy, compared to just 8% of G-type stars, which are similar to our Sun. If somehow this is true for all of these red dwarf systems, this would have a really big implication for the possibility of extraterrestrial life. But here there's also a really important side note. So far, detecting anything around planets in these star systems have actually been kind of challenging, and specifically detecting any kind of an atmosphere. And that's because red dwarfs actually complicate a lot of the analysis when it comes to the planetary spectrum. In many cases, because of the amount of star spots, they can actually be interpreted as something coming from the planet and not from the star, with many of these initial observations potentially being contaminated. Nevertheless, learning about this unusual star system approximately 40 light-years away from us is of course very crucial if we actually want to learn more about terrestrial planets out there, and if one day we want to discover some kind of an extraterrestrial intelligence, or even just some kind of a simple life. And this is actually our first topic. Just a few months ago, researchers did actually take a look at this star system by using a radio telescope. And here there was obviously just one goal: detecting some kind of an alien technology or some kind of an alien communication by observing the star system for approximately 28 hours. But in this case, they did use an extremely specific technique. A technique known as planet-planet occultation, which happens when one of the planets moves in front of the other planet and essentially presents us with a chance to potentially eavesdrop on any radio signals. And in this case, after these observations, they actually did discover over 2,200 potential signals, way more than predicted. But upon thorough analysis, none of these signals turned out to be artificial in origin. Pretty much all of them had some kind of a natural explanation. And so here for planets B and C, the two closest planets to the star, we can almost certainly say that no one on these planets is trying to communicate using radio signals. But even though these planets seem to not have any extraterrestrial communication, based on some of the recent studies, they do potentially have a chance to have atmospheres. And this is based on at least two separate studies that have reanalyzed some of the data from the James Webb, coming to slightly different conclusions from initial analysis. And so, for example, for the closest planet, TRAPPIST-1b, something really exciting was actually discovered by analyzing different frequencies of infrared light. Now, first of all, based on the distance from the star, we know this planet is going to be really hot. At least as hot as Mercury, possibly as hot as Venus. But the initial studies from approximately a year ago, which you can learn about in some of the videos in the description, came to a conclusion that there doesn't seem to be anything on the surface either, as in no atmosphere and no possibility of any kind of water. And this was discovered by doing a really intriguing analysis when we actually observed the star and the planet by seeing different sides of the planet as it orbits the star. And so here, during the orbit, different regions of the surface are going to be emitting different amounts of thermal infrared light. And in this case, if there is any atmosphere, we are going to be seeing additional emissions in certain frequencies, even from the dark side of the planet. For example, if there is CO2 here, it's going to be emitting certain frequencies of light that should be detectable to the James Webb. And so in the study we discussed last year, based on the infrared observations in 15 microns, the overall conclusion was that there was no CO2, and the planet was most likely completely barren. But in this new study, also Ducrot and her team reanalyzed the data by also adding another wavelength, 12.8 micron. And turns out that here, the actual observations were just a little bit different. Instead of having a very strong and a very stable 15 micron signature, the 12.8 micron observations could only be explained as one of the two potential scenarios. Either this was a planet with a very, very young surface, less than 1,000 years old, and essentially a result of extreme volcanism, the so-called magmatic bare rock, or this planet was filled with hazy, carbon dioxide-rich atmosphere extremely similar to Venus. But it could not be a barren rock like previously assumed, which would actually produce different observations, and obviously it could not be an Earth-like planet. And that's actually a really exciting discovery because by using this new technique and new modeling, researchers actually discovered that the planet B might be a lot more exciting than we initially thought, with a 50% chance of having atmosphere or 50% chance of being volcanically active, with a process known as magmatic resurfacing, rejuvenating the surface every 1,000 years, which would also imply geologic activity, and that by itself would be super exciting. But if it does have atmosphere, it potentially has something extremely similar to what we actually observe on Titan. Here's actually how Titan, Venus, and TRAPPIST-1b generally compare to one another. But in this case, because this planet is extremely close to the star, the atmospheric chemistry would be entirely different, basically making this a really bizarre planet we currently cannot even imagine. Likewise, a somewhat similar discovery was also made about planet C, the second planet from the star. A year ago, this was at first assumed to be also like an atmosphere, but a new analysis by Andrew Linkowski and his team, once again using very similar observations, focusing on 12 and 15 microns, also proposed a potential atmosphere that's just a little bit different from anything we imagined. And so even though this planet probably doesn't have a CO2 atmosphere, it might still actually have a really thick oxygen atmosphere, possibly as thick as 10 Earth atmospheres in terms of pressure. Or it can even be what's known as a steam atmosphere, where a type of a runaway greenhouse effect is basically driving liquid water into the atmosphere, turning this into a kind of a steam world. We've actually discussed these planets in one of the previous videos in the description. And so now planet C also has a chance of having a really bizarre atmosphere on its surface. Just not the atmosphere that was previously assumed, and not the ones we're used to right here in the solar system. With several additional studies, such as this one by Joshua Christensen-Totten and his team, even proposing that other planets do actually have a really high chance to not just have atmospheres, but also liquid water. And specifically as a result of a secondary atmospheric formation that would very likely take a few 100 million years, but would basically result in hydrogen reacting with oxygen and iron and producing water, heavier gases, and a lot of important compounds in very large amounts on the surface. Now in this case, this is just a model and a potential explanation. There is no physical evidence, but based on this model, there is now new hope. A hope for these planets to maybe contain something interesting. And according to this model, planet TRAPPIST-1e, the one in the habitable zone, has an extremely high chance to have atmosphere and thus liquid water. And not just some liquid water, here we're talking about a huge ocean. So definitely a really exciting proposition. And one of the last studies takes this even a little bit further. Here, Afonso Mota and his team wanted to actually find out how likely is anything to survive on these planets, assuming that something is exposed to superflares from a typical red dwarf and are basically living in these extremely hostile conditions. And the focus of the study was on something we know really well, Aspergillus niger, a type of a black mold that usually grows in soil that's actually known for producing a lot of melanin, that compound that basically gives us tan. And this mold tends to produce these really bizarre shapes where a large number of spores basically end up releasing peptidomelanin into the surrounding medium. In other words, they tend to produce the environment enriched in melanin, not just inside the cells, but even outside of the cells. It's one of the most prolific producers of melanin, allowing it to survive extremely high levels of UV radiation. And so in this case, researchers wanted to basically simulate how likely is this mold to survive conditions around a star like TRAPPIST-1. In this case, this was done by simulating the environment and allowing these spores to grow in various saline solutions. And even when simulating radiation based on a superflare in a typical red dwarf, here the overall conclusion was that the spores would survive and would even thrive in certain conditions, although not if directly exposed on the surface. Here they would have to be either inside water or underneath millimeters of soil. But more importantly, the more melanin they produced, the more likely they survived, implying that technically life could exist here, and technically could live inside these oceans if they exist. But that's once again just a theoretical proposition and a theoretical analysis. Obviously, we're not going to know if there is any life here for a very, very long time. But despite all of these somewhat positive and somewhat optimistic studies, there is still one major problem with these red dwarfs. And it's not the fact that they have so many flares or produce so much radiation. It's also the fact that when these stars are much younger, or basically when M-types are just born and start to develop, they actually undergo an extremely hot stage in the early development that in theory could produce very hot conditions on the surface of all of these planets, which would last for hundreds of millions of years. And in theory, this would evaporate everything, turning all of these planets into just molten crust. And so basically, as of 2025, we still have absolutely no idea what's happening here, and whether any of these planets have anything on their surface, or if they can ever host habitable conditions. But we'll definitely come back and talk more about this once there are some updates or some additional discoveries, or once James Webb conducts additional observations, possibly discovering something new. And today we're going to discuss some of the new and somewhat unusual discoveries coming from the center of the galaxy, but also discoveries that potentially solve a major mystery. A mystery in regards to what's known as hypervelocity stars. And so let's talk about this concept in a little bit more detail, but let's start with some explanations first. And I guess explanations in regards to stars moving in a galaxy. You obviously don't feel it, but right now the Sun is orbiting the Milky Way galaxy at 220 kilometers per second. And quite a few stars in a galaxy move at a relatively similar velocity, orbiting around the center, with each orbit usually taking a few 100 million years. But in the last couple of decades, researchers also discovered stars that move a little bit faster. For example, in one of the recent studies, citizen scientists, or basically amateur astronomers, discovered at least one object that actually even seemed to be a little bit too small to be a star and potentially was a brown dwarf that was moving across the galaxy at 600 kilometers per second. And this is actually faster than the galactic escape, which is believed to be anywhere from 520 to maybe 580 kilometers per second, which basically suggests that at some point this unusual brown dwarf will possibly escape the galaxy, which is why these stars are referred to as hypervelocity stars. Anything with a speed high enough to eventually escape the galaxy. And quite a few of these stars have been confirmed in the last few decades, suggesting that this is a relatively common phenomenon. But here the question has always been, what exactly forms them? What's the main mechanism that forms these stars? And well, one of the resolutions involved a binary system and basically a supernova. Once the supernova happens, it gives the partner star enough kick to start traveling at several hundred kilometers per second. Alternatively, maybe this involved some kind of a passage next to a black hole, for example a binary black hole system, where due to three-body system interactions, the third object will suddenly get a dramatic kick, once again reaching speeds of at least 500 to 600 kilometers per second. And though most of these scenarios seem to make sense for a lot of these observations, they don't make sense for some extreme examples. And that's because in the last decade, at least 20 of these stars have been discovered to have speeds over 1000 kilometers per second, basically double the escape velocity, which by itself would be extremely difficult to achieve. Here, even a supernova event or a passage next to a black hole would not provide these velocities. But based on observational evidence, researchers always had one potential explanation. And the explanation here made a lot of sense when you start tracing back the origin of these stars by looking at their vector of velocity. Many of them seem to have actually come from the center of the galaxy, and specifically the location of the central black hole, Sagittarius A star. And so here the explanation was that maybe this kick and this velocity was basically the result of the interaction with the central black hole, and specifically the interaction between a binary system where one of the stars gets kicked out or even swallowed by the black hole, and the second star suddenly achieves ridiculous velocities. And that explanation theoretically made a lot of sense, but there was just no physical evidence. As in evidence suggesting that this is even possible, or evidence of some kind of a precursor binary system where this could one day happen. Moreover, additional observations of this region actually revealed something extremely unusual. Here there seem to be a lot of young stellar objects and even a lot of young stars that seem to exist around the central black hole, but also seem to behave in slightly different ways. You can check out some of these stars in some of the previous videos about S stars and G objects, but in essence, many of these objects and many of these stars orbited in a very strange way, appeared extremely massive and extremely young, and in some cases even turned into some really strange clouds when approaching the black hole. Moreover, Sagittarius A star forces a lot of these objects to assume certain formations and orbit in certain ways, with many of these S stars even moving at several thousand kilometers per second in velocity. And so this bizarre three-dimensional organization, bizarre orbits, and of course the fact that these stars appeared extremely young all kind of made no sense. And that's because, technically, we actually expect only old and dim stars in orbit around the central black hole. There should be no young stars here, especially stars younger than at least a few 100 million years. But many of these stars appeared younger than 5 million years, suggesting that they either formed here or somehow managed to migrate here very quickly, none of which made sense. But there was actually one additional mystery. All of them were single stars. And that's actually the biggest mystery of them all. When it comes to massive young stars, especially stars that are super bright and visible from far away, in most cases they're always binary, or actually at least binary. In some cases they actually contain several stars. As a matter of fact, the majority of bright, massive stars are always at least binary. But that's not what was visible here. These were all single stars, and not a single one of them was a binary. And that was of course both a mystery and actually a potential explanation to everything. It essentially implied that the extreme environments very close to the central black hole most likely caused a lot of these stars to change dramatically, and maybe most of these were binaries, but then either merged or became disrupted over time. And so, for example, in this study by Devin Chu and his team, the discovery was that 16 young supermassive stars in orbit around Sagittarius A star were all single stars, even though they're expected to be binary. And more importantly, these were all S stars, or these stars with very strange orbits, and all of them appeared to be younger than 6 million years old. And so the conclusion here was that Sagittarius A star seems to destroy binaries and turn them into something else entirely. Something that can resemble very exotic objects such as the G objects, or possibly turning their partners into hypervelocity stars. But all of these were basically still assumptions, because we still needed to find at least one binary system in order to see if their existence around Sagittarius A star was even possible. Because then we can basically make an assumption that if a binary does exist here, it can eventually become one of these bizarre and somewhat difficult to explain S stars. And well, for the first time ever, this study right here from December of 2024 finally discovers such object. The first ever binary extremely close to Sagittarius A star that seems to possess just the right parameters to eventually become one of these bizarre objects. A star currently referred to as D9. A system in orbit around Sagittarius A star, and a system that's almost certainly a binary. And the reason scientists know this is based on the analysis of Doppler spectroscopy. Here, by looking at the star for several years, and by using the ESO's Very Large Telescope, they were able to measure the Doppler effect, or basically the redshift and the blueshift, revealing a wobble that happened every 372 days, which basically suggests that this is two orbiting objects, with the bigger object at 2.8 solar masses and the smaller object at 0.73. And they both seem to be orbiting at a distance of 1.5 astronomical units, which is much less than the tidal disruption limit, where basically the central black hole would rip apart a partner, turning this binary into a single star. But based on these parameters, and based on the orbit, scientists believe that in about 1 million years, this system is most likely going to change, either merging, becoming one of these G objects, thus possibly explaining their origin and basically suggesting that G objects seem to be merged binaries, or maybe tidally disrupting one of the stars and turning it into a hypervelocity star, possibly even eventually ejecting it from the Milky Way. And so basically by detecting the first ever binary around Sagittarius A star, we finally have several potential explanations for many of these mysteries detected in our galaxy. But there is one more mystery about this star as well. It actually appears to be 2.7 million years old. And so unless it recently came here and was then captured by the black hole, the origin of this star system is not entirely clear. Although it is possible that it might have been created in one of the nearby regions. We've actually talked about some of these star-forming regions in some of the previous videos in the description, but quite a few of these molecular regions do form new stars, and maybe this is just one of these binaries formed there. Either way, by detecting D9 and by basically discovering the first binary around Sagittarius A star, we finally have our first evidence that hypervelocity stars possibly result from binaries close to Sagittarius A star, and also evidence that Sagittarius A star transforms a lot of these binaries, turning them into entirely different types of objects, and many of them with extremely strange parameters. But that's basically all we know for now. And well, today, since I'm wearing my James Webb Space Telescope t-shirt, we're going to discuss one of the most incredible pictures captured by the JWST that you can kind of see behind me. The picture of the system known as WR140. Something we've actually discussed in one of the previous videos, but something that's worth discussing again because we now have another study that has actually conducted additional observations and additional analysis, producing something absolutely incredible and also confirming exactly what this system is and what we're actually looking at here. And so let's actually discuss what this is, why this is absolutely incredible, and why this actually confirms what we basically know about the evolution of galaxies and evolution of stars, while also connecting this to one of the recent videos and one of the recent studies we've discussed in regards to how carbon circulates across the galaxy, leaves the galaxy, sometimes comes back, and sometimes forms star systems and planets, with at least one of these planets eventually forming life, and basically you and I. In other words, this is actually connected to one of the recent discoveries on how carbon travels in a galaxy. But what exactly is this, and what are those weird wavy shells? Well, even though this might look like some kind of a refraction effect, or some kind of a halo from basically looking at this with a lens or with some kind of a glass, in reality, this is a physical object. These layers are real and they're kind of mind-blowing, and we finally have a direct proof, once again from JWST. And here's that incredible proof. A visual confirmation that these bizarre layers are moving, and moving really fast, approximately 1% of the speed of light, and are basically expanding away from the center where this binary system is located. And this is observations from just one single year. But something that was invisible to us until the James Webb Space Telescope. But in this case, what this observation confirms is of course what we kind of suspected from the beginning. This star system, for some reason, is throwing off huge shells of material, which seems to happen every 8 years, with each of these shells traveling across space at approximately 2700 kilometers per second. And the only reason we see them is because the light from the star illuminates them, producing tiny reflections visible from a distance. And so basically here we have this very bizarre system producing huge amounts of dust and huge amounts of material periodically blown into the universe through these massive emissions. But this is a really important observation because this finally confirms what the scientists always predicted. This system is a typical example of a cosmic dust production that enriches the galaxy with a lot of materials including silicon and carbon that's then responsible for forming planets and for forming life. And in this case, produced by a very unusual type of stars known as Wolf-Rayet stars. Once again, one of the videos in the description talks a little bit more about this, but in a nutshell, a Wolf-Rayet is a type of an extremely powerful, very bright, very hot star with very specific emission lines that very often form some of the hottest objects in a galaxy. This one, for example, is 200,000 Kelvin, responsible for ridiculously powerful radiation, making these stars so bright that the pressure from the light itself starts to basically throw off huge amounts of dust from around the star, making the outer layers evaporate over time. But intriguingly, most of the radiation is not in optical light, it's in the ultraviolet light. That's because they're actually so hot. And so instead of being super bright to our eyes, instead they start to illuminate a lot of gas around themselves, which usually produces a lot of different emissions depending on the atoms and the molecules involved. And in many cases, most of this gas came from the star itself, with huge amounts of oxygen, nitrogen, silicon, and carbon almost always visible in these emissions. As a matter of fact, one of the main definitions for a typical Wolf-Rayet star is the fact that they usually contain more emission spectra than absorption spectra. Or basically they're so bright that everything around them starts to glow as well. All of this the result of very powerful ultraviolet radiation that creates a lot of really bright effects in a spherical formation around the star. And so approximately 2 decades ago, back in the early 2000s, some of the ground-based telescopes were able to discover this new Wolf-Rayet star that seemed to possess 2 separate layers. And it was actually the Keck Observatory that discovered the first couple of shells around this unusual star. This was WR140. But almost right away there were hints of additional shells that were just extremely difficult to see. And mostly because these were not optical shells, these were only visible in the infrared. And because this was the 140th Wolf-Rayet star, it became known as WR140. And so the UV light from the star heats up the gas so much that it then starts to re-emit infrared light, producing these shells. And so once we had the most powerful infrared telescope in existence, James Webb Space Telescope, everything suddenly changed. Oh, look at that, there is a telescope just like that on my t-shirt that you can find in the description. Shameless self-promotion. Anyway, on a more serious note, some of the first images of the star from the JWST basically uncovered 17 shells as opposed to just 2. But much more importantly, each of these shells seemed to be separated by a relatively similar distance. And though at first researchers thought that maybe this is an artifact of the observations and just something that infrared light produces in this cloud, eventually they realized that this is a physical object and, more importantly, it was moving. And so additional observations for several months revealed that first of all this contained huge amounts of carbon, this was also moving at 2700 kilometers per second, and it seemed to happen every 7.9 years. which almost right away provided us with an explanation. This was basically an eccentric binary system, or a system with two massive stars, one of them a Wolf-Rayet star, that once in a while approach each other so closely that the gravity between them produces tidal effects and potentially throws off huge amounts of dust from the Wolf-Rayet star, which are then emitted at very high velocities, spreading away from the system faster and faster. Or at least that's one of the first explanations we have for now, because in reality it's still not certain why these concentric shells are formed in such a perfect way, and why there is so much coherence and symmetry between them, even though we expect these emissions to be much more sporadic and much more chaotic. But intriguingly, these recent observations basically confirm the velocity, and also the fact that initially these shells are moving just a little bit slower. They actually start with approximately 1800 km per second, but then seem to accelerate by 400 km per second every single year, with that acceleration decreasing away from the star, because it's the photons from the star that cause the acceleration. So basically the star produces enormous radiation pressure, and in this case, based on the number of shells, we're actually seeing approximately 130 years of emissions that have not changed much over time. And so this very strange episodic dust formation, and this is by the way the only such system we've discovered in the entire galaxy so far, seems to directly confirm how a lot of carbon and a lot of more complex atoms seem to form across the galaxy and seem to spread across the galaxy, eventually leaving the galaxy for just a little bit before coming back, colliding into large clouds, and restarting the star-forming process once again. And you can learn more about that in one of the recent videos in the description. Likewise, this is now a prototype for what's known as a colliding wind binary, which represents a star system with two massive stars whose interaction very often produces stellar winds with very periodic and very powerful emissions. And actually one of the most iconic such stars is Eta Carina. You can learn about that star and its bizarre emissions in one of the videos in the description as well. But this recent study by Emma Lieb and her team does actually make a few additional discoveries. First of all, there's finally a confirmation that a lot of this dust seems to be really clumpy, in some cases even forming relatively large chunks, which is extremely likely the result of wind collision from the interaction of these two stars. And here the observations confirm that there are even certain substructures inside these shells that seem to survive for at least 14 months, implying that this interaction forms relatively stable structures, all containing huge amounts of carbon. And more importantly, we now have evidence for what's known as PAH, or polycyclic aromatic hydrocarbons, which are known to be extremely stable and are also technically responsible for a lot of organic molecules on planet Earth, and are very often claimed to be the starting material for a lot of different stuff that eventually formed life on Earth. So basically here we have a kind of a life precursor in action. On top of this, there's now a confirmation that there are much older shells as well, but the shells that are just a little bit too difficult to see and are just too dim to detect. We basically have chemical evidence, but not visual evidence. Lastly, there's even evidence for huge piles of gas and enormous piles of dust, essentially forming these huge amorphous clouds, in some cases even as large as the solar system itself. But in this case moving just a little bit too fast to become an actual star system, with all this gas eventually making it outside of the galaxy before coming back in billions of years. And so in essence here we're observing the birth of future star systems and future planets that might form in the Milky Way in the next few billions of years, once this gas goes around in a circle and falls back into the galaxy through this unusual process of recycling of gas that seems to be present in pretty much every galaxy we've seen so far. But because this is a Wolf-Rayet star, and because it most likely started as a star with 25 solar masses in total, it is eventually going to possibly explode. So basically, it might produce a supernova, or, depending on the conditions, it might also just become a black hole collapsing directly. Either way, whatever happens, it's most likely going to release even more gas for thousands of years, eventually releasing at least half of its mass as these bizarre spherical shells. And the calculation from the study essentially suggests that over hundreds of thousands of years of the existence of this system, it's most likely going to generate tens of thousands of these dust shells, basically spreading away from the center, becoming less and less visible over time. And so approximately 13 solar masses of gas from within the star is at some point going to end up on the outskirts of the Milky Way inside its halo, before coming back for another round and potentially forming actual planets. And so here this bizarre binary system finally provides us with actual physical proof that shows us the process of enrichment and process of formation of complex elements, and also shows us how huge amounts of carbon and silicon end up in the outskirts of the galaxy inside its halo. And so for astronomers, this is a really important observation and not just some kind of a cool picture, even though it is a cool picture. But it's really this time-lapse or this tiny video that's basically the highlight of this new study. And today we're going to discuss a somewhat intriguing study that claims to have discovered evidence for a very bizarre type of a star, literally known as the strange star. And it's actually called that because of its properties and because what it's made out of, specifically strange quarks. And because in this case this is based on some of the more recent observations and observations from a very peculiar explosion, surprisingly right now this is actually one of the best explanations. And so let's discuss this new discovery in more detail, but I guess let's start with the explosion itself first and why it was kind of strange. And well, technically here there is not much to see, mostly because this was a gamma ray burst. And in this case a gamma ray burst that very likely happened billions of light years away from us, but was detected on May 29th, 2024. And just like with many other gamma ray bursts, this was almost right away picked up by a lot of different facilities. As a matter of fact, you can find the list of all of the reports about this event in one of the links in the description. There were 35 separate observations from different facilities and using different wavelengths, which actually highlights that we've technically entered the golden era for various detections in astronomy and specifically detections of gamma ray bursts. But when it comes to the origin of these events, there are still some unanswered questions, and specifically questions in regards to their origins, because a lot of gamma ray bursts produce different observations. Some of them can be very short, some of them last much longer, and some of them produce different wavelengths. And so today scientists believe that there might be at least 4 separate sources. The first obvious one is a massive supernova, or specifically a star collapse, that produces 2 very powerful jets. Or maybe this is some kind of a very powerful black hole, specifically a hyper-accreting black hole that's spinning very rapidly and produces powerful jets as a result. Or this is a collision of 2 neutron stars, which has been previously detected and confirmed to cause short gamma ray bursts. Or lastly, this could also be the result of some kind of a magnetized neutron star, or a millisecond magnetar, that seems to undergo some kind of a major change. And so depending on the source, gamma ray bursts might appear a little bit different. And well, the thing is, this recent gamma ray burst was actually kind of bizarre. And here it was bizarre because it seemed to produce several separate emissions. And specifically, it seems to have produced 2 separate episodes with approximately 400 seconds of quiet time between them, as if there were actually 2 explosions. This was observed by different telescopes and confirmed by different studies. And so this bizarre event with 400 seconds of quiet time doesn't actually make a lot of sense, at least using previous explanations involving black holes, colliding neutron stars, magnetars, or supernova. Here's actually one of these previous observations that even shows us potentially another event that happened approximately 100 seconds after the first explosion. And so in this recent study, Xiao Tian and his team proposed a really intriguing explanation that kind of matches all of the observations. What if this was actually a formation of a very bizarre object we usually call a strange star? A theoretical concept in physics where basically as stars get more and more density, at some point even neutron stars start to change into something else, changing all of their neutrons into quarks. And following this, if there's even more density, transform into different types of quarks. Okay, it might sound complicated, but basically here's what scientists think might happen as matter becomes denser and denser and as it reaches its limits before it turns into a black hole. We know that following certain types of supernova, the remnant becomes a neutron star, or basically a star where all of the protons and electrons combine, leaving behind nothing but neutrons. But previous studies have also proposed that inside these neutron stars, especially at very large depths, even these neutrons, because of the pressure, will start transforming into something else. They'll actually start losing their confinement and will suddenly create an ocean of quarks. So essentially those elementary particles everything is made out of. Here we're mostly going to have up and down quarks, but potentially some other types, because quarks tend to change into one another. But as the star becomes more and more dense, eventually most of the neutrons potentially convert into quarks, creating a hypothetical quark star. A star that might have some neutrons as the crust on top, but the insides are all quarks. In terms of mass it's going to be the same, but in terms of size it's going to be a little bit smaller. But this is not the end of the story, because as you condense quarks more and more, they'll actually transform into something else in order to achieve stability. And so at super high densities, all of the quarks start to change into strange quarks. In physics, this process is known as deconfinement, and it's essentially a kind of a dissolution of subatomic particles that first makes quarks free particles, but eventually forces some of these quarks to combine into strange quarks, forming more and more of this strange matter. And the more density the star has, the more strange matter it's going to have. Once again, just to clarify, this is only called strange matter because of the name of the quark, not because it's unusual or because it's weird. And it turns out that this particular matter is extremely stable. So stable, as a matter of fact, that once something becomes that, it's unlikely to change into something else unless there is some kind of a black hole nearby. And though it's possible for this strange matter to collapse further, forming a black hole, in theory these stars can exist for a very long time without changing anything. But all of this was basically just theory. Up until recently, there were no confirmations or really anything to actually suggest these stars exist. But once in a while we discover something here and there that seems to match predictions about these strange stars. For example, a couple years back, scientists discovered this bizarre compact object with the name you see right here that surprisingly resembled what we thought a strange star might look like. Mostly because this seemed to be some kind of a neutron star, but it was just extremely low in mass. It was about 77% of the solar mass, but extremely tiny in size and producing huge amounts of energy while also being surrounded by a supernova remnant. And even today there is still no better explanation for what exactly this is, but for all we know, this is maybe one such star right here in the Milky Way galaxy. But this new observation is unique for a different reason, because here we might have finally seen how these unusual objects are created, assuming of course scientists behind this paper are correct. And right now their explanation is technically the best. Because in this case, once again, it's difficult to explain why this explosion contained at least 2 but possibly 3 separate shocks. These very powerful episodes must have been caused by something absolutely extreme, and so a supernova or even a black hole would not produce this in this way. But here these X-ray emissions definitely confirm at least 3 separate events, powerful events, that happened minutes apart. And so researchers now believe they can explain all of this by combining this with ideas behind strange star formation. And so basically, that first event was the gamma ray burst, and this very likely produced some kind of a neutron star, potentially a magnetar. And intriguingly, following this first emission, there seemed to be some kind of a plateau or some sort of an X-ray afterglow that lasted for just over a minute. And to the researchers behind this paper, it suggests that this could not have been a black hole, and thus very likely involved a neutron star or a magnetar that's about to do something else. And that something else happens right here. This magnetar collapses into a quark star, which results in a second explosion. And then for basically a few more minutes, we see additional afterglow and additional emissions that researchers believe was a stable period, where the quark star mostly contained up and down quarks, but no strange quarks yet. And then finally we have our last transformation, where the quark star turns into the strange star as many up and down quarks transform into strange quarks, and as the quark star goes through a kind of a transition stage. And in this case, the quark star is actually believed to act kind of like a liquid, specifically a very homogeneous liquid, making these quark stars resemble enormous liquid objects. But this liquid stage doesn't last, and the cooling of the quark star starts to transform it into the strange star, with the liquid basically becoming a huge solid, or potentially even a crystal. And researchers here believe that it's this cooling process that we actually observe as the X-ray afterglow, with the final product basically being a strange star in a solid crystal form. Although interestingly, in terms of properties, it's very similar to a magnetar. So the two would be very difficult to tell apart from a distance, with the main difference being the size. It would be just a little bit smaller. So basically instead of being 14 kilometers, it might be 10. But many papers also suggest that these stars would very likely contain a crust made out of neutrons. And this neutron matter crust, which is also very likely solid, sometimes collapses. And this usually happens when some kind of an accretion happens from the outside, and basically a lot of matter falls onto the surface of these stars. And here, once the collapse happens, this creates a huge cascading effect that affects the entire quark star, releasing a huge amount of magnetic energy, with all of this happening ridiculously fast and very likely producing very powerful radio emissions. And so today this is actually one of the main explanations for what we refer to as fast radio bursts. Mysterious radio emissions detected all over the place, that you can learn more about in one of the videos in the description. And so assuming that this is indeed a formation of a strange star, And assuming we can confirm the existence of these stars, this might finally explain fast radio bursts once and for all, with these unusual FRBs just being the result of the interaction between the crust on top of a strange star or a quark star with some kind of a matter from the outside, and the stars themselves formed as a result of a collapse from a neutron star as it forms after the supernova. But obviously this is just one such observation, and until we find more of these gamma ray bursts, it's going to be impossible to prove if this is correct. And approximately a year ago, from when I'm making this video, I promised you a space explosion, and specifically a nova that was supposed to happen before September of 2024, that unfortunately still has not happened, even though this is already March of 2025. And naturally, quite a lot of people were not happy with this because we all wanted to see an explosion. Even though obviously it would not be that spectacular, just seeing this new star in the night skies for at least a few months would be kind of super cool. Well, guess what? Even though that nova still has not happened, we now actually have a very high chance for an actual supernova in the nearby galaxy of Large Magellanic Cloud. And if that supernova happens, it might be even more spectacular, and obviously one of those once-in-a-lifetime events we might not witness for quite some time. And so let's discuss this event and why scientists are super excited about it. But I guess first, let's start with the star, because technically we've discussed this many years ago, as this star used to be one of the largest, if not the largest, stars in the entire universe. A star you see right here, and this is the actual picture, taken with the Very Large Telescope, and being the first image of any star outside of the Milky Way. And the name of the star is WOH G64, or I guess WOH G64. And in this case, WOH is just three names of three different people that co-discovered the star back in the 70s. It was actually discovered by Professor Westerlund, Olander, and Haddon. And as I mentioned, this is a star in the Large Magellanic Cloud, the largest neighboring dwarf galaxy that's technically known for at least one other supernova that happened back in 1987. And technically this supernova basically served as a kind of a catalyst for the explosion of interest in astronomy for the next few decades. This was also the first time we've discovered neutrinos coming from an object that was not the Sun, from somewhere else in the universe. And while today this remnant is pretty well known, but it's the remnant in a location where there are a lot of massive stars, and quite a lot of stars that will eventually go supernova. And so discovering another potential candidate is not actually that surprising. But there is actually something really surprising about this star. And so as I mentioned, it used to be the largest star we've ever seen. It was approximately 1500 solar radii in diameter, with the main component being what's known as the red supergiant. As a matter of fact, I believe we discussed this star back in the days when I just started making videos, because it was indeed one of the largest, if not the largest stars known to us back then. Even though it was kind of similar to Betelgeuse and very similar red giants, it was just much larger. Here in this picture, the Sun is just a tiny pixel, so actually you're probably not going to be able to even see it. And even today, a lot of pages, including pages on Wikipedia, still list it as a huge red supergiant, which is technically not incorrect because this is normally what we expect of stars, as in we don't expect stars to change too much in mere decades, and once we establish a size of a star, it's extremely likely going to remain similar for thousands, if not millions, or maybe even billions of years. And this is basically where the star kind of shocked everyone. Even though we don't expect stars to change much in a period of just a few years, this bizarre star did. Because first of all, it's no longer considered to be a red supergiant. It's now considered to be something else. And this is really bizarre. So here's actually an illustration from 2007 of what the star was potentially like. So essentially, this image shows us a red supergiant surrounded by a very thick torus of dust that seems to be approximately 1 light year in diameter. And there's actually a lot of material in this torus, representing up to 9 solar masses of gas expelled over time. And that's because it was discovered that this star is also the fastest in terms of mass loss. Here it was discovered that the star seems to lose 3 to 5 solar masses every 10,000 years. And that's actually quite a lot. And not just a lot, it seems to be very unusual for a typical red supergiant. And as a result, this led to an extremely rapid evolution of this star, with these observations from 2007 now actually being super outdated. Because now it seems to be not a red supergiant, but what the scientists refer to as a yellow hypergiant that's dramatically smaller in size from previous observations. It used to be 1500 radii of the Sun, now it's only 800. And so in other words, since 2014 up until 2025, in just 10 years, it seems to have dramatically shrunk, transforming in a way we have never seen before, and basically becoming a completely new star that actually shocked the scientists behind the recent study. And as always, you can find this in the description, but here the European team, with the main researcher Gonzalo Munoz Sanchez, basically could not believe their eyes. Or I guess technically could not believe their telescopes, because here at first they thought they're looking at the wrong star, since the properties were entirely different. Not only was the star half the size, it also dramatically dimmed in brightness, especially with the red light, only producing approximately 1% of luminosity compared to previous observations, while at the same time dramatically changing its temperature as well. It used to be approximately 3200 Kelvin and used to have a lot of red color and even signatures of titanium oxide, which is apparently very common in these red supergiants, but now it was approximately 4700 Kelvin, and the emissions line were producing iron and nickel, but also a lot more blue color. So it was literally like looking at a completely different star, which is exactly what they thought at first. Yet it wasn't, it was the same star. And that's on top of a lot of other observations, including somewhat unpredictable variability. It seems to increase and decrease in brightness without any particular pattern, with luminosities changing in a way we've never seen before, which is I guess kind of similar to what happened to Betelgeuse a few years back. And so here the combination of these dramatic changes and very unpredictable changes in brightness imply that the star is definitely going through some dramatic changes super quick. And though obviously we have no idea what happened here, mostly because the observations between 2007, 2014 and now have been kind of sparse, whatever happened and whatever is happening seems to be kind of extreme. And not just extreme, it's never been seen before. Even the changes around Betelgeuse were not nearly as extreme as what we're seeing here. So basically, in a nutshell, it went from being a super active red supergiant into a very quiet, very mellow yellow hypergiant in what seems to be just maybe 5 years, with the most likely date of transformation being 2014. And as you can imagine, for astronomers, this is actually super exciting. As a matter of fact, this is the closest we've been to potentially observing a nearby supernova. Because at the moment, this is the best explanation. The extremely rapid transformation we're seeing could be just the signs of instability right before the star explodes. And if so, it might actually explode relatively soon. Not like 100 years soon, for all we know it could happen in the next few years. But there's always a but. So yeah, I don't want to raise your hopes too much. There are still additional explanations to what's happening, and these explanations do not involve a potential supernova. So first of all, scientists believe that this is actually a binary, and the presence of a second star, which has been hinted in a lot of observations of the light signature, might be responsible for these dramatic changes, especially the changes around the star itself. And specifically, one of the explanations here is that maybe this was actually the yellow hypergiant all along, but it was just actually being hidden by a lot of extra layers around it, which stayed here for a very long time, making the star appear much brighter, and also making it appear as one of the largest stars in the entire universe. But as the star became more active and potentially blown all these extra layers away, or as the partner orbiting the star eventually stripped all of these layers away from the star, the actual yellow hypergiant was finally revealed. And well, if that's the case, what we basically just observed is a transformation of a star that does not necessarily mean a supernova, but does once again suggest that sometimes a lot of these stars become extremely active and release a lot of material that basically covers the entire star system in a lot of this extra dust. Which is, I guess, in some sense, a somewhat similar explanation to what happened to Betelgeuse a few years back, except that in the case of Betelgeuse, it was a much smaller dust cloud, and it made Betelgeuse dimmer. Here, it's quite possible that this was just something way more dramatic and involved way more dust. But that's just an alternative explanation, because right now the supernova explanation is still technically the best. In other words, right now the assumption is that this was a red supergiant that suddenly became a yellow hypergiant because it's going through some dramatic changes before the explosion. Which means that the next step is to basically determine what evolutionary stage the star is in and how likely is it to explode anytime soon. And well, because of these discoveries, this is most likely going to be the most studied star for the next few years. I'm sure nobody wants to miss an actual supernova happening in real time. And so we're probably going to be hearing more about this star, which will hopefully also get some kind of a super cool name. And that's because right now, none of these names are easy to pronounce. Wach G64 just sounds like some kind of an insult out of Star Trek. But basically, until future discoveries and future observations, that's right now all we know. This is actually one of the most exciting discoveries in the last few months, especially when it comes to stellar evolution, and a discovery that was basically made completely by accident. Nobody expected the star to go through so many changes in just a few years, and most importantly, nobody has any idea what's going on. And in this video, we're going to be discussing some of the new observations out of James Webb Space Telescope of an unusual distant galaxy that potentially represents the first ever detection of a very mysterious type of a star known as the Population 3 star. Or to be more specific, we're going to be discussing a detection of a galaxy that seems to be made entirely out of first stars in the entire universe. And so let's talk about this in a little bit more detail, but let me first explain exactly what these population stars are and why detecting these stars is one of the main missions for the James Webb. And here all of this connects to the idea known as metallicity, the astronomical concept that basically defines elements in the universe as either metals or not metals. And in astronomy, there are only two non-metals, hydrogen and helium, with everything else after hydrogen and helium basically being referred to as metals. And though maybe not the best name to represent all of these elements, in essence what this means is that some elements like hydrogen and helium existed since the beginning of the universe. But everything after this, so things like carbon, oxygen, and pretty much most of the things on the elemental table, was actually created as a result of astrophysical processes. So basically everything from carbon to iron and gold. And over time, as the universe evolved, the fraction of metals compared to non-metals increased. So basically, even though initially there was mostly hydrogen and helium, as various stars were born and as supernova happened, and basically as the universe became enriched in a lot of additional elements, the entire universe started to become more metallic and chemically complex. And so in astronomy, this concept of metallicity is super important. But it's especially important when it comes to trying to figure out the star's age and the evolutionary process in regards to stars, and to basically find out how different types of stars evolved from one to another. And based on this metallicity concept, today in astronomy, all stars are divided into three different types: population 1, 2, and 3. And while stars like our Sun are basically some of the youngest stars and contain some of the highest amount of metallic elements. So essentially they contain a lot of stuff that's not hydrogen and helium, implying that they were formed after many supernova happened in the past. For example, for the Sun, it's actually believed that at least 40 supernova happened to create the amount of metals we observe in various solar emissions. And so when we look at the star and we discover that it's a population 1 star, or essentially a star with high metallicity, we also know that it's most likely going to have a planetary system along with potentially terrestrial planets. Naturally, because planets like Earth are made out of a lot of these metallic elements. As a matter of fact, Earth is composed of approximately 90 chemical elements, actually being mostly made out of oxygen and silicon and not hydrogen and helium, with Earth's core also containing a lot of iron, which is one of the end products for a lot of different supernova. And so for planetary sciences, population 1 stars are usually the most exciting. Then we have population 2 stars, basically the stars that eventually created population 1 stars like our Sun, and the stars that do contain fewer metals and are usually much older, but also obviously do contain some elements that are not hydrogen and not helium. Today most of the red dwarf stars are actually population 2 stars, but the more massive population 2 stars resulted in supernova and eventually produced stars like our Sun. But then there is the third population that we've never seen anywhere, and that's the mysterious population 3 stars, I guess the grandparents or the progenitors of everything. And these would be stars containing no metals, because these would be the first stars to appear and would be very likely extremely different from anything we've ever seen. Now, based on a lot of simulations, these stars are expected to be supermassive, very bright, and very hot. Basically blue hydrogen helium stars, possibly several hundred times more massive than the Sun, and very likely only existing for maybe 1 or 2 million years, which as a result means that it would be extremely difficult to actually capture them with a telescope, because their lifespan is not very long, and because we're mostly going to be seeing the leftover gas after the supernova, or possibly seeing population 2 stars that formed from all of this gas. And so based on a lot of different computer simulations and very detailed simulations, researchers essentially worked out what we should be detecting if we ever find them, and what these stars are most likely going to be producing in terms of the actual emission lines. And while in the last few years, there actually have been some hints of these stars, or at least their remnants, in a few different galaxies. For example, a few years back, we've discussed the detection of potential gas produced by these stars. And here this was basically gas that was very likely produced as a result of massive supernova, which implied that we're seeing what happened after these stars exploded, or that we basically missed these stars by just a few thousand or a few million years. You can learn about these discoveries in some of the previous videos or in some of the studies in the description, but this is basically what the scientists kept discovering over and over, either remnants or obscure signs that these stars potentially existed, but no exact detections yet. But approximately a year ago, we discussed this study, based on the observations from GNZ11, or the previous record holder for one of the farthest galaxies ever found, where scientists discovered the telltale signs of these unusual stars. Here there was what's known as the HEL line, or technically helium-2 line, which is a type of an emission usually produced by extremely hot helium. And here this could only be explained if this gas was strongly ionized by something super bright and super powerful. And it was actually located right here in the halo of the galaxy. And whatever this was, it was at least 500 times more massive than the Sun, which at least in theory resembled the mass of these hypothetical population 3 stars. And though once again not the exact observation and just the hints of these stars, this observation once again confirmed that the theories in this case might be correct after all. And well, now, approximately a year after, in 2025, we get a new study that potentially discovers even better evidence from a completely different galaxy, reported by Fujimoto and his team in a study you see right here, and this is based on a survey using James Webb Space Telescope known as GLIMPSE. And this survey contained 2 barely visible galaxies that researchers discovered were kind of unique and somewhat unusual. Unusual in a sense that they actually contain all of the parameters predicted by these population 3-star theories. And though one of the galaxies was just a candidate and the observations were not perfect, the other galaxy, known as GLIMPSE 16403, turned out to be super exciting. Exciting because this is the first time we've seen anything like this. First of all, this was an extremely compact galaxy. It's only approximately 140 to 150 light years across, and technically resembles some kind of a globular cluster, or an extremely early galaxy growing really fast. But much more importantly, it actually contained all 3 main features for population 3 stars. First of all, it had a very strong hydrogen alpha emission line. It also contained something known as the Balmer jump, and most importantly, it seemed to contain no dust and no additional elements indicating metals. In other words, if we actually compare this to the model or the prediction for population 3 stars, this galaxy was almost a perfect fit. But intriguingly, this galaxy existed when the universe was already 825 million years old. So this was actually closer and younger than the previously discussed candidate GNZ11. But because this galaxy contained very powerful hydrogen and helium emissions, and no signs of any metallic emissions, there was really no way to interpret this except for a galaxy with these population 3 stars producing huge amounts of luminosity and essentially stars that are probably going to be exploding very soon and producing additional elements. But as of right now, all of the stars in this galaxy seem to be pretty young, less than 5 million years old, with a total mass of all stars only being approximately 100,000 solar masses. So this is actually a really small galaxy, and even small for a typical globular cluster, suggesting that this is a galaxy that seems to be forming out of some kind of a primordial gas in what seems to be the middle of nowhere. And though it's still possible that this is just some kind of a metal-poor galaxy, or even some kind of a black hole or an active galactic nucleus, so far these are just alternative explanations, and the best explanation based on the emissions seems to be that this is indeed population 3 stars, and not something else. And so whatever is happening in this galaxy is definitely going to be discussed in a lot of future studies, because this is actually super exciting. We've never seen such a primordial galaxy ever before, and this could basically represent some kind of a really early seed for some of the future galaxies, where all of these stars, as they go supernova and as they produce a lot of new elements and a lot of additional emissions, continuously enrich the region around themselves, and possibly eventually grow larger and larger as more gas falls in and as this galaxy collides with additional galaxies. So for all we know, this is basically the first ever detection of a primordial baby galaxy. Literally a galaxy that's just a few million years old and was just created. But we need to have more observations and additional work before this galaxy and the additional candidate can be confirmed. Although assuming that this is correct and assuming that this is indeed population 3 stars, this would suggest that one of the primary missions for the James Webb has officially been completed. Discovering these stars and studying them is essentially one of the main reasons this telescope exists. And because this is such a grand discovery, here the researchers also end their paper on a somewhat philosophical note, basically reminding us that only 100 years ago, cosmologists finally discovered that the universe existed, and galaxies like Andromeda and Triangulum were actually separate galaxies and not part of the Milky Way. We've actually talked about this very recently in one of the videos in the description, but back in 1925, Edwin Hubble and a few other astronomers officially confirmed that the universe was much bigger. And now, 100 years later, we're talking about discovering some of the first galaxies at literally the edge of the universe, which is kind of mind-blowing. And today we're going to discuss a relatively famous, or technically infamous, pinwheel nebula somewhere in a galaxy that actually went viral a few years back because some of the initial observations and some of the initial studies actually suggested that one day this particular nebula is going to create something super dangerous for planet Earth. But now, after years of observations and because of the new study, we actually have some really exciting new discoveries and new evidence that whatever is happening inside this nebula seems to be even more bizarre than previously believed. And so today, let's discuss WR104, that media has previously referred to as the Death Star, for the reasons we're going to be discussing right now. But I guess first, so what exactly is this, and what are these pinwheel nebula? Because this is actually not the only object. As a matter of fact, we've discussed quite a few in the past, with some of the images even observed by the James Webb in a lot of detail. And in essence, these can also be referred to as Wolf-Rayet nebula, or basically nebula formed by some of the brightest and some of the most powerful stars in the entire universe. Really massive stars that are usually so bright and produce so much light pressure that they basically start to blow apart completely, releasing huge amounts of gas in the process. This is actually something that happens to stars either when they're super old, about to go supernova, or sometimes when they're actually really young. But as a result, they usually produce very beautiful nebula, visible from very far away. But they also have a tendency to not be alone. As a matter of fact, these stars are very often born with a partner, usually a much smaller star, sometimes an O-type star, that can actually create a lot of bizarre effects as it orbits the more massive Wolf-Rayet. And usually this results in a nebula that doesn't appear spherical, but instead appears a little bit deformed. And specifically because one of the stars here is actually spewing out a lot of dust, but the other star disturbs it through additional stellar winds. And as these stars interact with one another, and also as they orbit around one another, the collision between their stellar winds ends up producing a lot of beautiful emissions, and also produce something that appears as a spiral, which is essentially what we actually see in many different locations in the galaxy. And so this is all a result of the orbit and the interaction of the stellar wind, with the dust spiraling outwards due to the rotation of the system. And these stellar winds are actually super exciting and also extremely important, mostly because this is enormous amount of dust, but also because this interaction produces extremely complex molecules and just generally a lot of chemical interactions. As a matter of fact, these powerful winds produce many carbon-rich molecules and a lot of hydrocarbon dust that then enriches the entire galaxy and ends up in a lot of different star systems millions and billions of years afterwards. And so technically this is also a kind of a carbon-based fountain. A fountain that enriches the entire galaxy, and because a lot of these molecules are technically carbon-based, technically this is also the fountain of life, producing many different molecules that eventually ended up inside of us. And so these molecule collisions produce this beautiful formation visible in the infrared, with the actual spin of the spiral usually depending on the orbit between the two stars. And while in 1999 the WMKEK observatory discovered yet another one of these spirals, but this one was kind of different. Because this was the 104th Wolf-Rayet star, it became known as WR104, but these new images were somewhat unusual. Mostly because the shape of the spiral in this case basically implied that this particular star system was inclined almost directly face on toward us. Or in other words, the rotational axis of this binary system was directed approximately toward our own planet. And though at first this was kind of ignored, within just a few years researchers actually started to ring the alarm. And that's basically for one important reason. At least one of these stars, or possibly even both of these stars, had a slight chance to produce gamma ray bursts. Okay, let's quickly go through this as well. Now first, you might want to check out one of the previous videos in the description about the brightest gamma ray burst we've ever seen, the one that was only discovered in 2022. But here, even though this particular gamma ray burst happened billions of light years away from planet Earth, in a galaxy far, far away, it was actually able to affect the atmosphere of the planet, changing it enough that its effects were very similar to a typical solar flare. And that was of course because it was ridiculously powerful. And it also lasted a really long time, approximately 7 minutes. But once again, this was really far away, billions of light years away from us, in a barely visible galaxy you see right here. And though we're still not entirely clear how exactly gamma ray bursts are formed and why they seem to happen sometimes and not other times, one of the major implications from this discovery was that here we had two stars whose orbital parameters suggested that if one of these stars does go supernova, and they certainly will in the future, there was actually a chance that one of them might also create a local gamma ray burst. But not billions of light years away, only 8400 light years away from us. And if in this case this gamma ray burst is pointed at us, that might become a bit of a problem. The extinction type of a problem. Which is of course why the star received a new nickname, the Death Star. But despite the name, there were still obviously a lot of uncertainties. The first one was quite obvious. Even though we know the Wolf-Rayet star and the O-type star will go supernova, and possibly within the next few tens of thousands of years, it's not certain that any one of them will produce any gamma ray burst, or even any powerful emissions going toward our planet. Likewise, it was also not entirely certain what inclination these stars had, and if it was actually 0 degrees, or something closer to maybe 10 degrees, which technically would not be as big of a deal even if there was a gamma ray burst produced, because in that case it's just going to miss the planet and will not even be visible from planet Earth. And that's because these jets are usually extremely focused. And so here there was just a lot of uncertainty. But nevertheless, there was still that small risk. And the risk was actually big enough for a lot of researchers to focus on the star for many, many years. And we actually talked about some of the recent discoveries in one of the videos in the description, but now we have this new research that finally answers most of the questions and presents us with a completely new mystery that currently has no answer. And so let's discuss this new study by G.M. Hill, who used the observations from the WMKEC Observatory and several additional instruments such as low-resolution imaging spectrometer, a shell spectrograph and imager, and the near-infrared spectrograph, in order to finally confirm exactly what's happening and if we should basically be worried at all. And it's really the spectrographic observations that make this study so different, because in this case the researcher actually focused on the stars in order to determine their exact motion around one another. In other words, he basically disregarded some of the previous assumptions about their orbit and about the inclination that seems to be visible by observing this spiral. And so here, by measuring these spectra directly, it became possible to determine exact velocities for these two stars, which allowed the researcher to work out their exact orbits and exact inclination, with the observations definitively confirming the period. Basically here the orbit takes 241 days, and it seems to be almost entirely circular, but also discovering something really strange. The inclination was actually not 0 degrees, but very likely between 34 degrees to maybe even 45 degrees. In other words, the stars were not pointed at us at all, and the orbit was actually quite inclined. And because of this tilt of at least 34 degrees, it almost certainly ruled out any potential danger to planet Earth. Even if there is a gamma ray burst in the future, it's not going to point at us at all. It's just going to go in a completely different direction. And once again, that's because these jets always travel along the rotational axes in two opposite directions. They cannot travel toward us at all. But the previous assumption that was based on the observations of the spiral now basically created a bit of a mystery, because here, this actually suggested that in this pinwheel star, the star's orbit and the dust spiral were for some reason tilted toward one another. Or essentially, this unusual spiral seemed to be produced in a way we cannot possibly explain right now. Something else is happening in the system that produces the spiral inclined toward us, while the stars seem to be inclined in a different direction. In this case, the study doesn't actually provide any explanations, just a new mystery. But because of this particular discovery, the scientists in the study also suggest that we need to reinvestigate other spirals, or basically take another look at a lot of these other pinwheel stars in order to work out their exact inclination, but to also maybe find a way to explain this, because right now it just doesn't make sense. Nevertheless, these new observations essentially recalculate everything. And so here we have a Wolf-Rayet star that's maybe about 13 solar masses in mass and is throwing out huge amounts of material, and we have an O-type star that's maybe 30 solar masses that will very likely survive a little bit longer, but will also go supernova in the next million years. And for some reason, their interaction, or specifically the solar wind interaction, produces a tilted dust spiral that, for all we know, might actually be a very common occurrence. It's just never really been seen before. And here, a lot of this was confirmed by detecting a lot of carbon and helium with very specific lines that are known to be produced through various colliding winds. And so the actual observations were pretty accurate. But because in this case this is pretty far away from us, over 8,000 light years away, and because both stars are still pretty stable, even if there is a supernova in the next 10,000 years, it's basically just going to appear as a bright star and have practically no effect on the planet, which I guess kind of downgrades the star from being potentially dangerous to a typical pinwheel star. But naturally, assuming that something similar happens around other pinwheel stars, maybe this also means that some of the other inclinations could potentially be facing us after all. And so once there are some additional discoveries, we'll definitely come back and talk more about this in some of the future videos. And until then, I guess looks like you're gonna have to go to school or to work tomorrow after all, because no gamma ray burst is going to be causing extinction anytime soon.